Hi guys, welcome back to the channel. Today, we're diving into one of history's wildest chapters, the year 536 AD, when a volcanic eruption dimmed the sun, dropped temperatures, sparked famine, plague, migrations, and even set the stage for empires to rise and fall. Buckle up as we explore how a single disaster reshaped politics, religion, and the map of the medieval world. If you love epic deep dives, smash that like button, subscribe for more history breakdowns, and ring the bell so you never miss an upload. Finally, drop a comment telling us what time it is where you're watching. Imagine yourself waking up on a summer morning in the year 536 AD. You pull back the crude linen that shields your window, expecting golden dawn, but instead, you meet a sky the color of damp charcoal. The sun hangs somewhere behind that ashen veil, a ghostly disk that neither warms your skin nor brightens the earth. Day after day, you watch crops curl before they ever ripen, livestock shiver in July, and neighbors swap rumors of omens. This is the moment you're stepping into now, an age when the world itself seemed to falter, leaving every community you know poised on the brink of disaster. You feel the chill long before you see its effects. In northern fields that once echoed with midsummer chores, farmers huddle by low fires, trying to coax life from soil that now feels like late autumn. Tree rings, invisible to you but preserved for modern science, will one day testify that growth nearly stopped altogether. Wherever you travel, whether through mist-soaked valleys of Britain, dense forests of Scandinavia, or across the high plateaus of the Andes, the story is the same. Saplings stall, oaks drop their leaves too early, and vineyards rot in dank gloom. You can almost taste the panic, like smoke from a fire nobody can locate. Word spreads along every trade route you ride. In distant Constantinople, officials scribble notes to each other about the sun shining without rays. On the opposite side of the world, Chinese chroniclers record a yellow dust that drifts like ghost snow across rice paddies. You swap tales with merchants who speak of red-tinted rain near the Gulf of Mexico and report that the summer monsoon has failed to arrive on India's western coast. Each new rumor feels heavier than the last because they confirm what you see outside your own door. Light itself has thinned, and with it, the promise of life. Food shortages arrive quietly at first. Your granaries empty a month earlier than usual, but caravans that once carried surplus grain from the Fertile Crescent stall at half strength. Their beasts have died on roads choked by early frost. You try bartering for dried fish from coastal villages, only to find nets hauled in barren. Salted meat trickles south from the nomads' herds on the steppe, yet the price is triple what you paid last year. When you bite into a precious loaf meant to feed 5, its coarse texture reminds you of desperation. Coarse barley mixed with acorn flour, bitter and gritty, but life-sustaining all the same. What strikes you next is the silence of empty fields. Children who should have been chasing fireflies under long twilight skies now cough in crowded huts. Young men march off to protect dwindling storehouses against the desperate. They return weeks later, thinner, carrying tales of villages abandoned overnight. You notice funeral chants rising more often, performed for infants whose mothers could no longer nurse, for the aged whose fragile bodies surrendered first, and for travelers done in by cold they never expected in midsummer. Wherever you ride, bells toll, sometimes bronze, sometimes wooden, sometimes nothing more than a drum, but always for the same reason. Yet even amid loss, your curiosity sharpens. You press herbalists, priests, and astronomers for answers. They blame portents, a rivalry of planets, a dragon devouring the sun, punishment for war, greed, or lust. A wandering sage spares you a different vision, describing a mountain far to the south that tore itself apart, spewing so much ash into the sky that day turned to twilight around the world. You picture that chasm vomiting fire and dust high enough to ride the jet stream, though you don't know its name, until every horizon resembles the one outside your home. In centuries to come, scientists will hammer sulfur-rich ice from Greenland's glaciers and confirm the sage's intuition. But for now, you settle for myth, because myth feels like guidance when nature itself refuses to explain. With each passing month, you sense the social order fray. Taxes go uncollected because fields sit barren. Armies shrink as conscripts desert to scrounge for their children. Kings who once ruled by divine favor hold emergency gatherings, debating whether to disband courts and follow the harvest in search of edible weeds. Clergy proclaim that the end times have arrived, urging repentance, fasting, and tithes, if you can spare them. Bandits multiply on wooded roads, no longer content with coins. They demand bread. You ride armed even to visit your cousin in the next village, scanning tree lines for desperate eyes. Still, you adapt. You learn to seek calories wherever they hide. Hardy turnips planted in raised beds, nettles boiled to soften their sting, and mushrooms harvested quickly before they spoil. You resew every garment, layering wool on linen to trap any warmth you can steal from a weak sun. When autumn slides into winter, without the usual fanfare of harvest festivals, you huddle around stoves that burn peat, animal dung, anything combustible, to heat a single shared room. Conversation drifts to the same question over and over. Will the light return next year? Nobody knows, and hope becomes a kind of currency, traded in stories that tomorrow might break clear. Travelers eventually bring hints of improvement. Faraway farmers report days when the sky, though still hazy, brightens enough to cast distinct shadows. Rivers once sealed by ice begin to flow earlier than last season. You step outside one dawn, and for the first time in memory, feel real warmth on your cheeks. The experience is so foreign, you forget to breathe, then laugh aloud at the ridiculous joy of sunlight. In that moment, you realize what has been missing is not just heat, but color. A sky shifting from lead gray to pale blue. A robin's breast flashing orange where only soot hues reigned. Yet relief carries its own burden. Scarcity has changed human maps, pushing tribes into conflict over arable edges, toppling city-states that once thrived on robust trade networks, and crippling empires that ruled by granary and sword. Even as harvests recover, you watch new political alliances form, forged by common hardship. Old dynasties fall while enterprising warlords seize depopulated lands. Some communities adopt radical faiths promising cosmic rebirth. Others retreat into fortified monasteries, preserving knowledge in anticipation of the next calamity. All around you, the world rearranges itself, as if a reset lever has been pulled. In quiet moments, you reflect on the chain of events that linked your daily life to planetary forces. A mountain exploding thousands of miles away clouded the skies above your village, triggered frosts that killed your neighbor's wheat, weakened immune systems, and paved a path for plague that would soon arrive on infested fleas. You comprehend, perhaps for the first time, that history is less a march of kings than a delicate dance with nature's volatility. When one domino falls in the tropics, another wobbles in your backyard. Looking back from the vantage of modern science, you could quantify that darkness. An 18-month veil reducing solar radiation by perhaps 2 to 4%, enough to shave several degrees from average temperatures worldwide. You could chart cereal yields collapsing in Europe, dendrochronological tables showing unprecedented ring width minima, and paleoclimate reconstructions revealing drought belts that stretched across hemispheres. But standing in 536 AD, you simply feel smaller than you ever imagined, humbled by a cosmos able to dim the very source of life without warning. And yet, as you ride through fields where green shoots now rise tentatively, you understand resilience. Communities that survived have done so not through isolation, but interdependence, sharing seed varieties, exchanging medicinal knowledge, expanding family networks beyond bloodlines. Even in crisis, you find ingenuity, new crop rotations, improved granary ventilation, revised calendars tracking subtle regional climate cues. The lesson you carry into better seasons is clear. Vigilance must pair with cooperation, because no wall is high enough to bar airborne ash, no sword sharp enough to cut famine in half, and no empire eternal enough to outlast a sunless sky. So when you return to the channel's introduction, when you buckle up for that deep dive into how catastrophe reshaped politics, religion, and migration, you're no longer a distant observer. You've walked the dim streets, tasted the bitter bread, and felt the fragile spark of hope that followed the darkest year. By placing yourself in that uneasy dawn, you can grasp why this event still echoes today, reminding you that in any age, civilization rides on the thin light between abundance and want, and the next sunrise is never guaranteed. You step away from the flickering campfire of 536 AD and into a modern lab, but you don't lose the story's thread. You carry it on your fingertips, dirt still under your nails from those barren fields. The room glows white, humming with freezers and microscopes, and you watch technicians slice razor-thin wafers from a block of ancient spruce. Each sliver is a time capsule whose rings speak louder than any chronicler. When the cross-sections slide under the scanning lens, you see the years of your remembered darkness reduced to pale, stunted bands. They look almost like a skipped heartbeat on an electrocardiogram, confirmation that the planet itself once staggered. Lean in closer. On a normal timeline, a tree ring widens after a warm, bright summer and narrows after a harsh one. The pattern is as dependable as sunrise, until it isn't. Here, the normally steady rhythm plunges in the mid-530s as though the tree were gasping. You trace the skinny lines backward. Finland, Ireland, Siberia, California, even the high reaches of the Andes all show the same abrupt constriction. You realize this isn't some regional anomaly, but a planetary bookmark. It's as if nature pressed pause at exactly the moment you stepped into that charcoal dawn. Now your guide hands you a core from an Irish oak waterlogged in a bog since the early Middle Ages. Its rings, pickled in tannins, glow chocolate brown under LED light. You run a finger along the grain and imagine its sap barely circulating during those sunless summers. That single tactile sensation, rough cellulose, stubborn yet starved, tethers your lived memory of cold nights to empirical proof. From wood, you glide to ice. Deep beneath Greenland's serene surface, a drill brought up frozen cylinders banded in powdery white and dusky gray. Annual snowfalls captured in a high-pressure archive. You watch a scientist chip a milligram of ice from the layer dated 536 AD, dissolve it, and feed it to a mass spectrometer. Sulfate spikes appear on the monitor's neon graph, towering over background noise. You feel a jolt of recognition. This is the airborne ash that blotted out your skin, imprisoned inside ice for nearly 15 centuries. It carries the fingerprint of a tropical volcano, its isotopic ratio revealing that the eruption sprayed aerosols into both hemispheres. Seeing the data, you picture again that phantom sun glowing dull and blurred. Only now, you grasp the chemistry that made it so. Your journey continues to a lab in Arizona where bristlecone pines stretch like twisted sages across a high desert ridge. They're alive, old enough to have tasted that ancient darkness as saplings. Dendrochronologists here practice a craft that feels almost priestly. They chronicle tree rings to the nearest year, then stitch overlapping lifespans into one unbroken timeline reaching back 10 millennia. You help align cores on a long table, adjusting them until ring widths snap into perfect sequence, like a giant barcode of climate. When the composite reaches 536 AD, every volunteer in the room goes silent. The suppression is unmistakable. You sense awe, but also responsibility, because these lines aren't mere statistics. They are diaries of survival and setbacks, grief and resilience. To widen your perspective, you step into a windowless vault lined with sediment cores pulled from the bottoms of Scandinavian lakes. Each core holds layers of pollen, dust-fine memories of forests and fields. High-resolution imaging reveals a sudden decline in alder and birch pollen right after the volcanic winter, replaced by hardy grasses that colonize abandoned farmland. You remember the barren fields you once crossed on horseback and realize farmers elsewhere faced the same crop failures, leaving the earth to opportunistic species. The evidence grows tactile again when you handle lentil-sized grains of volcanic glass, tephra, extracted from peat bogs in northern Europe. Their chemical signature matches certain Indonesian volcanoes, hinting at a blast powerful enough to fling microscopic shards halfway around the globe. They glint under microscope light like black diamonds, each one a passport stamp certifying its journey through the atmosphere before landing in a distant swamp. You imagine inhaling that glassy grit on a day when your lungs already burned from cold. Modern modeling steps in, and you slip on augmented reality goggles. Suddenly, a 3D world spins before you, showing atmospheric circulation patterns that loop aerosols around the equator, then loft them towards the poles. You trace the path from the tropics to the Arctic, watching ash clouds dim irradiance across continents. Computer code translates your anecdotal dread into numeric reductions of solar luminosity, maybe a 2 to 4% cut, but enough to shrink tree rings worldwide and to tilt empire and ecology alike. You feel vindicated. The ache you once described as a sunless season is now quantified in watts per square meter. Back on solid floor, you flip through leather-bound facsimiles of medieval monastic records. You read entries about a noontide twilight and a failure of wine and wheat. Those lines align perfectly with the tree ring minima and the sulfate peaks. The synergy between written testimony and physical proxies turns skepticism into conviction. It's not just that monks, scribes, or Chinese court historians remarked on a dim sun. It's that spruce, oak, bristlecone, and glacial ice all corroborate their laments. Earlier you trusted your senses. Now you trust a mesh of independent witnesses, botanical, cryogenic, geochemical, each echoing the same calamity. This synthesis reshapes how you see causality. During your 536 experience, you once wondered whether dragons consumed the sun or whether some celestial tribunal meted out punishment. Here, under lab lights, you accept a subtler truth. Earth's climate can hinge on a single tectonic outburst, magnified by atmospheric dynamics and expressed through biological proxies. The rings remind you that climate is memory written in cellulose. Ice bubbles are memoirs in crystalline form. Pollen counts tally ballots cast by plant species on who survives and who fades. Yet raw data also carries human stories. A dendrochronologist shows you a chart of ring widths plotted against known outbreaks of plague. You watch the line plummet first in the 530s, then again in the 540s when the Justinian plague strikes. you realize that the tree's struggle mirrors human vulnerability. Malnutrition from crop failures would have thinned immune defenses, allowing Yersinia pestis to rampage. One discipline complements the next. Tree rings diagnose climatic stress. Epidemiology reveals biological consequence. Archaeology unearths deserted settlements. You stand at the nexus, translating between these languages. Newer tools, stable isotope analysis, laser ablation microtechnology, add high-definition footnotes. Oxygen isotopes in stalagmites from Chinese caves capture a 2-year dip in monsoon intensity. Right when your charcoal-colored dawn began. Even ring patterns in subfossil oak preserved beneath German rivers show isotopic signatures of cooler growing seasons and heightened soil moisture, explaining why so many hillsides slid in lethal mud flows. Each lab you visit layers nuance atop your memory. The event wasn't simply cold. It scrambled hydrological cycles, shifted storm tracks, rewired ecosystems. Every organism left breadcrumbs for science to find. You start noticing how these proxy records function like overlapping camera angles of the same catastrophe. Where a chronicler's parchment might burn or fade, a bristlecone's xylem endures. Where a court historian's scroll can be censored, a glacier keeps its secrets frozen until drilled. Cross-validation between sources yields a chain of custody stronger than any single document. That strength, you realize, doesn't just reconstruct the past, it warns the future. If ash layers or sulfate spikes return in coming decades, we will recognize them sooner and maybe pivot faster to protect global food systems that remain as fragile as those medieval granaries. Stepping out of the lab, you glance up at today's sun, bright and generous above a city skyline. You imagine its light filtering through skyscraper canyons and picture how those beams would dim if another mega eruption occurred. In that moment, you're not just a tourist of history, you're a steward of hard-won knowledge. The evidence locked in rings, ice, and sediment teaches you that civilization's margin of error is thin, but awareness broadens it. Every spreadsheet of tree ring widths, every isotope graph taped to a freezer door, is an early warning beacon, one you helped interpret by straddling eras. And so you carry this story forward, linking your visceral memories of hunger and fear, the rigor of modern science. Where once you judged the skies by the color of dawn, now you also read sulfate concentrations and varietal pollen counts. The world still holds volcanoes capable of painting tomorrow gray, but now you know where to look for the first pale rings of distress and how to respond before famine and plague return. That knowledge doesn't erase the darkness you survived. It illuminates it, ensuring that your experience becomes a tool, not just a tale. You leave the climate lab still hearing the whir of spectrometers in your ears, but now you trade microscopes for manuscripts. The air grows warmer and dustier as you descend a spiral staircase into a vaulted archive whose shelves climb like forest canopies of leather and parchment. Glass-paned lamps cast a buttery glow on scribe's ink, and you realize that the data you've just verified in rings and ice never stood alone. People living through that dim decade tried to record it in the only medium they had: words. Your job is to read their voices as carefully as you once read dendrochronological graphs, testing each sentence the way a lab tech tests a sample. You begin with a slim Syriac codex attributed to John of Ephesus. The vellum pages crackle when you turn them, releasing a faint scent of almond oil and smoke. His hand, steady yet crowded, tells of a year when the sun gave forth its light without brightness, like the moon, and it appeared exceedingly feeble. You pause, struck by how his metaphor echoes the spectral sun that tree rings silently confirmed. He writes of famine gripping the countryside, animals dying where they stood, and fields sprouting confusions of weeds. You remember those pollen counts that favored grasses over crops, and you feel the synergy between bone-dry science and this vivid lament. Setting that volume aside, you glide west in both geography and language to the bureaucratic Latin of Cassiodorus, a statesman in Ostrogothic Italy. His official letters, written to justify delayed grain shipments and rising taxes, complain of skies blended with ashes and shadows at noon. You notice he's not a preacher of doom, but a manager, forced to devise policies when shipping routes fail because sailors can't navigate under a persistent haze. His measurements may be imprecise, yet the administrative urgency rings true. You picture grain doles shrinking, riots simmering in Ravenna, and the same political tremor you modeled when you saw empire-wide tax receipts plummet after crop collapse. A cart rolls past, stacked with bamboo-bound scrolls bearing neat Chinese characters. You borrow one labeled with a reign title spanning the 530s. The court historian records that yellow dust rained like powdered gold, and that cold devastated the rice in midsummer. He adds a note that the emperor ordered prayers at temples of the 5 peaks, followed by emergency grain distributions in the Yangtze Basin. Suddenly, your map of catastrophe stretches beyond the Mediterranean. The monsoon failure traced in oxygen isotope stalagmites now has a human face. Boatloads of rice paddies lost, officials scrambling to avert rebellion, entire prefectures petitioning for relief. You next unroll a Japanese chronicle, the Nihon Shoki. It describes the year of red snow, when flakes fell tinted by volcanic dust, confusing farmers who feared the kami had turned against them. Ritual dances were performed. Offerings were cast into the sea. You compare that red snow with the tephra shards you held under a microscope only hours earlier. 2 witnesses speaking different tongues, yet describing the same phenomenon. One is chemical silica. The other is cultural symbolism. Together, they sharpen the outline of a global event. Moving north, you consult the annals of Ulster. The entry is brief, but chilling. A failure of bread in the 12th year. The sun showed a half-light. Irish monks rarely embellished. Their terse notes function like seismograph spikes in a quiet line of copyists. You imagine a scriptorium smelling of tallow and damp wool, where a monk pauses mid-illumination to jot that cryptic line before the flickering hearth sputters out again. His bare-bones style offers no explanations, only evidence. Yet the date aligns with the same narrow tree rings your dendrochronology team plotted across Ireland's bog oaks, parallel strokes in different alphabets. Across the Atlantic, you find a Nahua codex whose pictographs portray maize stalks stunted and people holding empty baskets toward a gray sun. Though scholars debate the exact chronology, radiocarbon dates on accompanying wooden glyphs cluster around the 6th century. You contemplate how an oral tradition could encode climate trauma in symbolic art, then carry it through conquest and plague to meet you here in a climate-controlled vault. That convergence between iconography and analytical chemistry feels almost miraculous, reminding you that truth often arrives in composite form, stitched from disparate threads. Not every text you parse is straightforward. In Procopius, you read of wars and wonders, and a reconquest bogged down by plague and provisioning setbacks. He grumbles about imperial ambitions more than meteorology, yet between the lines you infer the same supply failures Cassiodorus documented. On another shelf, the Chronicle of Zuchnin blends fact and apocalypse, claiming demons rode the winds. Rather than dismissing his spectral horsemen, you recognize their psychological utility. When night refuses to seed dawn, minds reach for monsters to fill the void. You jot margin notes linking such visions to mass trauma responses studied by modern psychologists after volcanic eruptions in Indonesia and Iceland. Cross-checking these chronicles, you notice a striking temporal sequence. The dimming begins in early spring of 536. Crop failures peak that summer. By autumn, caravans thin. Letters from Constantinople mention market prices tripling. Within 6 years, Procopius documents the outbreak of a plague that historians will later tag with Justinian's name. You see cause and effect winding like threads in a tapestry. Aerosol-driven cooling leads to malnutrition. Malnutrition weakens immunity. Plague rides trade routes already destabilized by hunger. The stories on parchment parallel the spikes in sulfate and the suppressed ring widths, confirming that data and narrative are not adversaries, but partners. You pause to reflect on methodology. In the lab, error bars encircle every value. Here, bias and genre shape every sentence. A hagiography might exaggerate famine to magnify a saint's charity. A royal edict could downplay it to avoid panic. Your task resembles textual stratigraphy, peeling back rhetorical layers to reach the bedrock of shared observation. Skies dim, crops fail, people suffer. Whenever you extract one such kernel, you align it against proxy records like aligning tree cores on a measuring bench. Concordance becomes the gold standard. Discrepancy sparks fresh questions. Dusk settles outside, yet the archive guards its own daylight. You light no candle. Micro floodlamps hiss quietly as you photograph folios, tagging them with coordinates in your growing matrix of evidence. You realize you're recreating a medieval newsroom, aggregating eyewitness dispatches into a multidimensional weather report. And just as meteorologists today plot storm tracks using sensors, you map spectral references to the sun across time and geography, turning anecdote into geospatial data. Before leaving, you open one last text, a Coptic homily from Egypt. The preacher describes a veil over heaven, through which light dribbles like weak wine, urging alms for widows whose husbands perished on Nile barges stranded by low floods. His plea is both theological and logistical. The low Nile corroborates hydrologic reconstructions showing reduced precipitation in East Africa. You close the manuscript feeling the weight of distant sobs meeting modern graphs. The synergy is overwhelming enough that you step outside the archive and inhale cool night air, grounding yourself in the present. Walking back under an urban sky, free of ash, bright with neon, you realize the chronicles perform one more function. They coach empathy. Ice cores quantify despair, but parchment gives it a name, a face, a prayer whispered over a dwindling loaf. By weaving those personal shards into your scientific lattice, you animate the numbers with lives lived under that muted sun. And just as point-blank measurements trained you to spot early warning signs in tree rings, these narratives teach you to listen when today's journalists, farmers, or satellite feeds hint at emerging anomalies. History's scribes hand you a vocabulary for recognizing crisis as it unfolds, not merely as a temperature graph, but as hunger lines in a market, rumors in a port, or silence in a once busy forum. So you carry their voices with you the way you carried dendro samples, carefully, respectfully, aware that each one lengthens the shadow of that forgotten catastrophe, just enough for modern eyes to see its outline. Where proxies mapped the physical contours of the disaster, these testimonies illuminate its moral landscape. The choices, fears, and resilience that science alone can't fully convey. Together, they form a composite lens, sharpening both past and future at once, reminding you that warning signs are measurable but also readable, if you cultivate the art of attending to them. You leave the archive with dust on your cuffs and questions on your mind. So many witnesses agree that the sky dimmed, harvests failed, and people starved. But none could see far enough beyond their own horizons to say why. You decide to test the most dramatic rumor that echoed through their pages, the belief that something from the heavens struck Earth and blotted out the sun. It feels intuitive. A flaming rock could cast ash into the stratosphere, break trade routes with tidal waves, and terrify every scribe into writing of omens. Still, intuition is not evidence, so you begin the slow work of elimination. First, you visit a remote stretch of Icelandic shoreline where basalt cliffs meet North Atlantic surf. Geologists here have mapped every obvious impact scar across the globe, from the gaping Chicxulub Basin that doomed the dinosaurs to smaller pockmarks in Siberia and Quebec. They hand you satellite composites showing no new crater from the 6th century, none big enough to match a truly sky-darkening blast. You imagine trying to hide a scar hundreds of meters deep and dozens of miles wide. Tectonics cannot heal it in just 1,500 years. The absence isn't proof by itself, but it signals that if an object fell, it must have landed in deep ocean. That leads you to a marine geophysics lab in Southampton, where sonar charts line the walls. Researchers here specialize in impact tsunami deposits, layers of chaotic sand, gravel, and shredded shells that betray massive seaborne shockwaves. The Mediterranean, North Atlantic, Indian, and Pacific basins all keep layered records of sudden inundations, yet cores dating to the 530s show nothing like the thick debris blankets you'd expect from a Chicxulub-style splashdown. Instead, you find calm sequences of clay and silt, interrupted only by an occasional regional earthquake. You gently set aside the sonar maps, feeling the first thread of doubt tug at the cosmic impact idea. Still, you need to rule out a smaller strike by analyzing extraterrestrial fingerprints, iridium, nickel, and other elements rare in Earth's crust, but common in meteorites. In a clean room at Lamont Doherty Earth Observatory, you watch technicians vaporize microscopic flecks from polar ice dated between 534 and 538. Mass spectrometry graphs bloom on a monitor, but their peaks align with volcanic sulfur and chlorine, not with iridium's telltale spike. Comparable test runs on sediments from European peat bogs and Chinese lake beds yield the same verdict. Chemical ratios point downward, into magma chambers, rather than outward, into deep space. You turn next to tektites, glassy beads formed when an impact melts crust and flings it skyward. Vast strewn fields stretch across Australia and Indochina, each tied to an ancient collision. Yet none of those fields match 6th century radiocarbon brackets, and no new field sits unexplained on the map. Gemologists loan you microscopes to search for microtektites in ice cores. You find volcanic shards, angular and full of trapped gas bubbles, rather than the smooth glass marbles born of cosmic fury. The pattern repeats like a refrain. Whatever darkened the skies was born of Earth, not stars. A skeptic in your own mind raises a counter-argument. What if a comet disintegrated mid-air, like the Tunguska blast of 1908, leaving no crater but plenty of dust? You chase that hypothesis into astrophysical journals, learning how high-altitude explosions distribute submicron particles. The Tunguska event scorched trees across 800 square miles, yet even it failed to measurably cool global temperatures. For a comet to cast a shroud over the world, it would need to detonate with orders of magnitude more energy and leave nitrates, charcoal, and magnetic spherules in ice layers. Those markers appear only faintly in 6th century strata, nowhere near the density of the 774 to 775 solar flare signature or the 1258 volcanic sulfate surge. The numbers just won't stack. You begin to appreciate how many lines of inquiry converge on no. No crater, no tsunami layer, no meteoritic iridium, no global blanket of tektites, no nitrate spike from a comet's atmospheric detonation. Negative results rarely feel triumphant, yet each one tightens the noose around competing explanations, sharpening the silhouette of the real culprit. You recall the chronicles that described dust rather than fireballs, cold rather than burning embers. Ancient authors loved spectacle. Had they seen blazing stones rain from the sky, they would have framed sermons around it. Their silence on meteors becomes another data point. Absence of evidence leaning toward evidence of absence. With cosmic avenues narrowing, you return to volcanoes, but this time with an eye toward differentiating surface eruptions from colossal caldera events. You travel by helicopter over the Sunda Strait, where whitecaps churn around Anak Krakatoa, the child of the volcano that famously annihilated itself in 1883. Modern sonar reveals older submarine cliffs encircling the strait, remnants of a far larger caldera collapse, perhaps the 535 monster long suspected. Core samples from the seafloor include pumice-clasts chemically matching Krakatoa's magma series and dated via argon-argon clocks to somewhere between 530 and 550. You feel a jolt of recognition, the chemical twins of the ash trapped in Greenland ice. Yet you keep skepticism alive. You ask seismologists about other candidates: El Chichon in Mexico, Ilopango in El Salvador, Rabaul in Papua New Guinea. Each boasts a massive eruption within a few centuries of your window, and each could have lofted aerosols stratospherically. Multiple flights of drones sniff sulfur emanations from crater lakes, comparing isotopic signatures to trapped aerosols in Antarctic ice. Statisticians run Bayesian models weighing eruptive volume, latitude, and atmospheric circulation. The probability curves peak decisively around a low-latitude, high-volume event, precisely the scenario a Krakatoa scale blast delivers. Still, probability is not certainty. You dive into tree ring series that resolve individual months. Some show cooling spikes within a single summer, then partial rebound, suggesting a rapid initial dust veil followed by sustained sulfate haze. That pattern aligns neatly with a volcanic eruption, but would be hard to achieve through a comet, whose dust disperses faster and lacks sulfuric acid to prolong cooling. Couched in dendrochronology jargon, the trees whisper, "It was the volcano." The clincher comes when you examine mercury anomalies. Massive eruptions vent mercury along with sulfur. Impacts and comets do not. In peat deposited near Trondheim, Norway, layers dated to 536 display mercury enrichments quadruple the baseline. Parallel enrichments show up in Alaskan bogs and German mires, all synchronous. When you overlay those peaks on sulfate curves and tree ring minima, the lines dance into near-perfect synchronicity, like constellations finally resolving into a recognizable shape. At that moment, you accept that volcanic fury, not cosmic bombardment, draped the 6th century world in twilight. Your journey of elimination teaches you an unexpected discipline: humility. It is easy to imagine apocalyptic fire from the heavens. Harder to sift through sediments, chemical graphs, and statistical models until only one explanation survives. The process feels like sculpting by subtraction, chipping away every hypothesis that leaves a missing chunk, whether crater, tektite, iridium, or tsunami, and revealing a core of coherent evidence. You realize that skeptics of future climate crises may demand the same rigor: show the fingerprints, match the isotopes, trace every ripple. Lessons from the past arm you for debates you have yet to enter. Stepping outside the laboratory, you look up at a clear afternoon sky. Passenger jets streak contrails that dissipate within minutes, tiny, harmless clouds compared to the veil of 536. You imagine for a moment a comet tail flaring overhead or a meteoroid roaring through the atmosphere. The absence of such sights reassures you, but it also underlines a sobering truth. The most powerful forces threatening civilization often hide underground, not in the heavens. They brew unseen until pressure lifts a slab of crust and sprays sulfur into winds that circle the globe in days. By ruling out celestial culprits, you don't merely solve a historical mystery, you redirect modern vigilance. Satellites already track near-Earth asteroids, but caldera volcanoes in Sumatra, the Andes, or Yellowstone sleep under thin crusts, only sporadically monitored. The 6th century lesson whispers that surveillance must look downward as well as outward. In your mind, you begin drafting contingency maps, flight path reroutes, seed bank expansions, sulfur scrubbers on power plants, policies that carry the weight of 15 centuries of warning inscribed in ice, ash, and neglected chronicles. You walk away feeling lighter, paradoxically, because narrowing the field of causes clarifies the field of action. The 6th century darkness was volcanic. Volcanoes are terrestrial. Terrestrial hazards can be modeled, monitored, and, to a point, mitigated. Knowing what did not happen clears space to prepare for what might. In that clarity lies a fragment of hope, forged not from dramatic impact craters or blazing comets, but from the quiet, cumulative power of negative evidence and disciplined doubt. You fly north to a research station perched on the rim of the Greenland ice sheet, a place where wind screeches over exposed drums of fuel and nothing grows taller than the snow stakes marking the safe path from camp to lab. Inside a corrugated hut, you shoulder cold, stiff parkas aside and meet a team uncrating a cylinder of ice almost twice your height. Each band in that glassy pillar is a winter's snow pressed into silence, and together they form a vertical diary of the sky. You've come because, after dismissing meteors and comets, you need affirmative proof, a signature you can point to and say, "This is the mark of the eruption that dimmed the world." Technicians anchor the core on a cradle and slice it into sections the length of your arm. You help label bags, careful to keep chronology intact, top layers from recent years. Gius, deeper layers from centuries past, until you notch the depth that mathematics predicts will hold the mid-6th century. The room smells faintly metallic as a microtome shaves the first translucent curls. Meltwater drips into a plastic vial destined for ion chromatography. Minutes later, the instrument's screen flares with jagged peaks, each representing an anion: chloride, nitrate, then sulfate. One spike towers so high it crowds the graph's margin. You know immediately you are looking at the chemical echo of a cataclysm. Sulfate doesn't drift into the stratosphere by itself. It rides there in the breath of volcanoes. When sulfur dioxide meets sunlight and cold, it oxidizes into a fine aerosol that reflects radiation and lingers for years before settling onto snow. The magnitude of the peak now glowing on the screen dwarfs any modern eruption curve, including Pinatubo's. You run your finger under the timestamp printed beside it. Late winter of 536. 2 centimeters above, another lesser surge occurs 4 years later, hinting at a follow-up blast that rekindled the chill just as crops were starting to recover. What chronicle or legend could capture such precision? Yet here, a frozen chemical ledger writes the date in absolute terms. Still, location matters. You need to know where the plume originated. A colleague brings over tiny ash shards filtered from the same layer, mounts them on a glass slide, and swings the stage beneath an electron microprobe. Each shard sparkles like a broken star under magnification. Elemental ratios: silicon, aluminum, calcium, iron, print out in crisp columns. Comparing them to a global database of volcanic glasses, you see the highest correlation with arc volcanoes in the Sunda region of Indonesia. The chemical fingerprint lines up with what you observed aboard the helicopter over the Sunda Strait. Remnants of a primordial Krakatoa system, wrenched apart in an outburst on a scale modern humans have never witnessed. To corroborate hemispheric reach, you board an ice-penetrating plane to Antarctica, where a parallel program has drilled cores from the plateau at Dome C. Data arrives by satellite telemetry before you even land. The same sulfate mountain rises in those southern records, synchronized within months of the Greenland layer. That simultaneity reveals the blast had punched through the tropopause near the equator, tapping the Brewer-Dobson circulation that ferries aerosols both northward and southward. No comet could have loaded sulfur unevenly between hemispheres. No temperate zone eruption could have stepped across the equator with such authority. The planet itself confirms the low-latitude volcanic hypothesis you shaped in the previous investigation. Back in a modeling center, you watch supercomputers ingest the sulfur signal and compute radiative forcing. Colored maps swirl on wall-sized screens as sunlight dims by up to 4 watts per square meter in mid-latitudes. Simulated wheat yields tumble, monsoons retract from India, snow cover lingers into what should be spring. You recall how medieval rice collectors petitioned their emperor, how Cassiodorus begged for grain shipments, how Irish monks recorded half light. Now the model overlays those anecdotes with physics, connecting sky chemistry to soil misery. You feel the power of interdisciplinary proof. Chemistry writes the headline, climate physics drafts the story, and human testimony fills in the faces. Because sulfur does not travel alone, you analyze trace metals that ride the same plume. Mercury joins the sulfate curve like a shadow. Volatile, poisonous, distinctly volcanic. In peat bogs across Scandinavia and Alaska, mercury concentrations quadruple exactly where tree ring widths crash. That parallelism converts coincidence into causation. You realize you can now stack 4 independent proxies: sulfate, ash chemistry, mercury, and ring suppression, to pinpoint the eruption's timing, magnitude, and likely latitude. The alignment tightens into something almost audible, like tumblers clicking into place on a long-stuck lock. Yet you revisit the archives, compelled to see whether scribes caught a whiff of chemistry in their metaphors. A Syriac chronicler mentions rain that stung the tongue, possibly tasting of diluted sulfuric acid. A Chinese observer writes of yellow dust, a poetic stand-in for aerosol haze. You note these fragments not as proof, but as echoes, vivid hints that people unconsciously registered the same chemical veil you now chart with precision instruments. The past doesn't merely survive in snow. It murmurs through language, waiting for modern ears attuned by laboratory evidence to discern its signal. Your last stop is a workshop where engineers design sensors for stratospheric balloons. They hope to monitor future eruptions in real time, scanning for sulfur-bearing plumes the moment they breach cruising altitudes. You realize how the 6th century ice core guides today's technology roadmap. Knowing the mass of sulfur that crippled agriculture 15 centuries ago sets thresholds for emergency response. Once satellite spectrometers detect a similar load, global agencies can trigger crop insurance reserves, reroute supply chains, and adjust climate models within hours. The darkness you once walked through on horseback becomes a calibration point for protecting a planet linked by jets and fiber optics. You step outside the facility into a bright afternoon. Contrails stripe a blue dome unmarred by haze. Under that benign sky, you feel the paradox of your journey. Understanding how fragile the atmosphere is makes the ordinary sun feel like a privilege. Ice remembers what happened when sulfur clouds robbed the world of warmth and color. Your task has been to translate that frozen memory into living policy. You think of farmers in Bangladesh who watch monsoon onset dates slide by a single week and wonder if the pattern signals another distant blast. Of grain traders in Chicago staring at satellite vegetation indices, of health officials modeling mosquito ranges after volcanic winters. Every one of them, knowingly or not, now leans on the sulfate peaks you traced across ice. In the end, the proof you sought feels both tiny and vast. It lives in micrograms of melted snow, in atoms counted by machines so sensitive they quake at a fingerprint. Yet it swings empires and rewrites ecosystems. It erases boundaries. An Indonesian volcano snows chemicals onto Greenland. Antarctic ice archives Asian dusk. Latin bureaucrats and Chinese mandarins leave parallel footnotes in the same planetary ledger. Holding that realization, you grasp why science and history must walk side by side. Instruments quantify what witnesses felt. Chronicles humanize what graphs predict. Together, they render the darkness of 536 not just a calamity to remember, but a manual for how to read the sky when it darkens again. You leave the ice lab with sulfur data fresh in your notebook and head south toward the equator, determined to give that chemical spike a face, an actual mountain capable of blasting so much ash into every corner of the sky. Your route follows the sulfate trail into maritime Asia, where the Pacific and Indian plates grind like slow gears beneath an arc of restless volcanoes. As your plane descends over the Sunda Strait, you peer through the window and see a scatter of green-capped islands ringed by turquoise shoals. They look idyllic until you picture the missing piece, a vanished summit whose womb-like caldera now sits below sea level, hinting at a prehistoric detonation more violent than anything living memory contains. On deck of a research vessel, you watch echo sounder displays paint the seafloor in sweeping blues and yellows. A bathymetric ridge rises abruptly, then drops into a moat more than 1,000 feet deep, an underwater amphitheater that dwarfs the modern cone of Anak Krakatoa, poking defiantly through the waves. Geophysicists explain how that basin likely formed when a magma chamber emptied so fast that the roof collapsed, ripping open vents that spewed ash into the stratosphere. They compare sonar profiles to those from Toba, Tambora, and Santorini, then let you decide. The footprint here is wide enough, the walls steep enough, to match the magnitude you calculated from the sulfate peak in Greenland ice. But geomorphology alone won't date a catastrophe. You lower a gravity corer, pulling up a column of gray mud studded with pumice clasts the size of lentils. Back in the ship's lab, you wash the mud through sieves and pick out shards of volcanic glass that twinkle like black sugar. An onboard mass spectrometer hums as it measures elemental ratios: potassium, titanium, iron. The fingerprint lines up with the shards trapped in both polar ice caps. The analyst calls it a highly plausible match, but you want more certainty. Numbers stamped in radiocarbon ink on organic debris that lay beneath the ash. A launch ferries you to Rakata, one of Krakatoa's surviving fragments. Beneath tangled roots of pandanus and fig, charcoal from ancient forest fires lies preserved in tephra fallout. You watch a field team slice a block of soil, wrap the charcoal in foil, and tag it for shipment to a carbon dating lab in Copenhagen. Weeks later, the result lands in your inbox. Calibrated calendar age of 532 to 545. CE, a time window that hugs the ice core spike like a clasped hand. You feel a jolt of vindication, nature itself time-stamping its own wound. Still, Due diligence requires you to examine rival suspects. Satellite imagery carries you to Central America, where Lake Ilopango fills a gigantic crater in El Salvador. Geologists there show you glass shards too, but their chemistry leans more rhyolitic, and their definite eruption date, circa 431 CE, arrived a century too early. Over in Mexico, El Chichon's pumice fits chemically. Yet radiocarbon numbers slide toward the 8th century. Each candidate teaches you a trick of elimination. Eventually, your list whittles down to 2 low-latitude giants, an undocumented outburst of Rabaul in Papua New Guinea, or this shadow caldera below the Sunda Strait. Rabaul's ash never appears west of the Indian Ocean, yet Krakatoa's dust shows up in East African lake beds, Middle Eastern peat, and perhaps even the Nile floodplain. Coverage matters. Krakatoa wins. You travel next to the University of Rhode Island to meet Haraldur Sigurdsson, the volcanologist who first hypothesized a 6th century mega-eruption at Krakatoa. In his office, rock cores lie stacked like oversized cigars. He saws one open to reveal a distinct layer of coarse ash rich in calcium plagioclase. "That's our smoking gun," he says, tapping a fingertip against the gritty surface. He pulls a thin slice from his microscope stage and invites you to look. Channels of vesicles frozen in the glass prove that magma once degassed explosively, and melt inclusion analysis reveals sulfur concentrations off the charts. You compare those sulfur values to the load back-calculated from ice core sulfate, and the numbers dovetail within experimental error. Separate disciplines rhyme once more. To chase one final piece, you ride a zodiac into the strait at dawn, when the sea shimmers pewter and fishing outriggers drift like silhouettes. A sonar towfish trails behind the boat, mapping buried pyroclastic flows that extend miles from the caldera rim. These submarine ignimbrites thicken precisely where historical models predict wind would have blown ash during a dry season eruption. Back aboard, a software overlay projects them onto reconstructions of 6th century trade routes. You note how debris blankets line up with lanes used by Roman, Persian, and Malay merchants, the arteries that later pumped plague across continents. The eruption didn't merely darken the skies. It clogged maritime commerce with floating pumice rafts for months, perhaps years, compounding the economic shock you saw in Cassiodorus's letters. Even literary breadcrumbs point here. In Chinese court chronicles you revisit, scribes report thunder coming from the southwest sea in 535 and fog that reddened the dawn. Days later, scholars long argued these cryptic lines refer to distant thunderheads, but you plot the capital's coordinates against Krakatoa's and realize southwest aligns exactly. A 7th century Javanese poem from the Bujanga Manik cycle speaks of an island, split asunder, flame taller than Meru, sound like 1,000 gongs. Oral epic might exaggerate, yet your sonar and ash cores suggest it preserves a kernel of truth. You return to the numbers, feeding all evidence into a Bayesian attribution model. Ice-sulfate mass balance, hemispheric distribution, glass chemistry similarity scores, radiocarbon brackets, written chronicle directionality, and tephra dispersal extents. The posterior probability tops 90% for Krakatoa, leaving single digits for Rabaul and statistical crumbs for every other candidate. The model's bar graph confirms what your gut already felt standing on Rakata's shore. This was the volcano that turned the 6th century gray. With identification settled, you turn toward scale. Modern Krakatoa's 1883 eruption ejected roughly 10 cubic kilometers of rock and chilled global temperatures by maybe 0.3 degrees Celsius. Ice core sulfate says the 6th century blast expelled 3 to 5 times that sulfur. implying a volume upward of 40 cubic kilometers, or 4 tamboras. Climate model ensemble runs add those figures to mid-6th century solar insolation curves and reproduce the precise two-step cooling event you saw in tree rings. An initial plunge of nearly 2 degrees C, partial rebound, then another smaller dip 4 years later, likely from a sibling eruption deeper in the same arc. Before leaving Indonesia, you hold a community meeting in Anyer, a town devastated by Krakatoa's 1883 tsunami, and now rebuilt with seawalls and evacuation sirens. Villagers listen as you share the saga of their caldera's older, bigger tantrum. You emphasize that warning systems, satellite sulfur detectors, real-time seismic nets, resilient seed banks, were born from studying this very history. A local teacher raises a hand and asks how long before Anak Krakatau grows large enough to repeat its ancestors' act. You can't promise centuries, only probabilities, but you gift her a laminated chart of global ultra-Plinian candidates and suggest adding volcano drills to disaster curricula. History, you tell her, is not a chain anchoring people to despair. It's a lighthouse telling mariners where reefs once tore hulls apart. Your flight home arcs high over the Indian Ocean, tracing the same jet stream conduits that once ferried ash. You glance at the in-flight map and imagine black dust swirling above the equator, dimming sunlight on the deck of some 6th century dhow. Identification satisfies a deep curiosity, yet it also burdens you with foresight. Now that you know a single volcano beneath tourist-laced waters can starve continents and topple empires, unlikely loses its comfort. In its place grows a sharper resolve to read seismic murmurs, to map magma chambers, and to embed volcanic scenarios into every climate risk model that guides food security or pandemic planning. As the plane banks toward a sunset unstained by ash, you close your notebook. Krakatoa's secret, once buried beneath centuries of coral, pumice, and myth, now stands unveiled as the architect of the darkest year. Ice cores gave you the chemical manifesto. Fieldwork carved the return address. Your journey from sulfate spike to shattered tropic island welds geology, history, and policy into a single narrative arc, reminding you that whenever nature speaks in riddles, persistence and cross-disciplinary listening can still decode the message before it needs to be lived again. You have traced the fingerprints of the blast from shards of glass on Rakata's slopes to sulfate buried in polar ice, but the picture is still static, an X-ray without motion. To understand what the eruption actually did to the living world, you step into a climate modeling suite where rows of processors glow like city skylines at night. Here, scientists translate rock chemistry into gigabytes of code, instructing virtual oceans to heave, clouds to condense, and jet streams to writhe. They invite you to load the parameters you just hauled back from the Sunda Strait. 40 cubic kilometers of ejecta, 90 teragrams of sulfur dioxide, an injection column piercing the stratosphere at 30 kilometers. You hit run, and the planet on the wall-sized screen begins to breathe volcanic dust. Within simulated hours, an umbrella cloud balloons over maritime Southeast Asia. You watch it radiate outward, glinting crimson under a low sun, then split into twin plumes that hitch a ride on equatorial easterlies. One branch arcs west across the Indian Ocean, turning skies ochre above the Horn of Africa. The other, glide path, heads east into the Pacific, curling over the Andes and finally converging at high latitudes. It is like watching dye. Sin swirl in a glass of water. Beautiful until you remember it carries famine in its wake. Aerosol concentrations saturate the tropopause so quickly that by the model's second day, a diffuse veil spans 1/3 of Earth's circumference, Surface temperatures fall next. In the color bar, tropical seas fade from turquoise to denim, mid-latitude landmasses from gold to dull olive. Global mean temperature slips by nearly 2 degrees Celsius in the first year, 5 times the drop after Pinatubo. You lean closer as cold anomalies deepen over the North Atlantic, nudging the jet stream southward. Storm tracks pivot, dumping rain where deserts usually bake, and starving fertile plains of moisture. The model's crop yield module flags maize belts across Mesoamerica as failed, barley fields along the Rhine as critical, and rice paddies on the Yangtze Delta as stunted. In less than 10 minutes of compute time, you witness a planetary food system stress test more severe than any modern drought cluster. Precipitation maps reveal another twist. Sulfate particles act as cloud condensation nuclei, but they also shade the surface, cooling ocean skin layers and throttling evaporation. The Indian monsoon, normally powered by land-sea temperature contrasts, arrives late and weak, its moisture budget sliced almost in half. The Sahel, perpetually on the edge of viability, slides into red flag aridity zones that stretch farther east than during the 1970s Dust Belt crisis. You recall the Nile records you skimmed in the Cairo library. 7 palms breadth below expected, scribes lamented. The model now prints the same verdict in 21st century units, seasonal flow deficit of 30%. As year 2 unfolds on screen, you see high-latitude snowpack persist through what should be midsummer. Albedo feedback kicks in, white surfaces bouncing sunlight back to space, locking cold in place. Sea ice in the Barents and Bering Seas grows thick enough to choke coastal fisheries. Trade winds weaken, piling warm water against the Central Pacific and birthing a monster El Niño-like state. Eastern Australia flips from drought to flood. Andean glaciers, starved of sublimation but still calving under their own weight, feed rivers swollen with silt. The formerly clear causal chain, eruption causes cooling, expands into a web of repercussions, altered currents, warped rainfall, ecological whiplash. Human modules enter the loop. Grain price indices spike 6-fold in the Mediterranean matrix, triggering civil unrest flags. The Byzantine Empire's tax revenue proxy collapses under lost harvest tithes, mirroring Cassiodorus's bureaucratic panic. Simulated caravan routes blinking across Central Asia show a 40% contraction in volume, forcing traders to risk higher latitude passages vulnerable to Avar raids. Exactly the migration you traced in chronicler's frightened prose. Even disease simulation lights up. Cooler, wetter conditions drive rodent population explosions in East Africa, and modeled shipping manifests show infected fleas hopping onto grain vessels bound for Alexandria. The code is not storytelling. It is math. Yet it reproduces the very cascade you pieced together from parchment, peat, and pollen. Halfway through the 3rd simulated year, the aerosol veil begins to thin, but momentum keeps the climate from snapping back. Ocean heat uptake has lagged. Terrestrial carbon sinks cough CO2 as cold-stressed forests die back. The model projects a slow recovery, 5 to 7 years before temperature, precipitation, and crop yields return to pre-eruption norms. You spot a second, smaller aerosol pulse representing the follow-up blast 4 years later. Cooling re-intensifies, prolonging hardship into the next decade. This 2-step scenario corroborates the double trough you saw in bristlecone pine rings and the second famine mention in the Annals of Ulster. Again, independent lines of evidence fuse into a single, self-consistent narrative. With the run complete, analysts hand you a slideshow of key outputs: radiative forcing curves, monsoon shift vectors, agricultural failure maps. You study a panel showing regional power vacuums, purple for collapse, yellow for resilience. The Levant glows purple, foreshadowing Persian-Byzantine attrition. The Arabian interior glows yellow, hinting at new societal experiments fueled by camel caravans, commandeering neglected trade corridors. You picture nomads finding fresh pastures where once settled farmers abandoned parched fields. In that context, the rapid rise of a new religious movement a century later seems less miraculous, more like an emergent property of reconfigured resource networks. Stepping away from the screen, you recognize that models, like chronicles, are partial views of truth, formal hypotheses rather than frozen fact. But they give you something parchments can't: the ability to rerun history with tweaked sliders. You dial the sulfur load down by half. The model suggests mild cooling, manageable harvest losses, negligible plague spread. You double the load. A little ice age snaps into place, deep enough to spark continental glaciation in Scandinavia. The exercise exposes a knife-edge reality. Civilization depends on a narrow climate bandwidth, and volcanic variability is one of its sharpest blades. Turning toward the future, you feed modern population grids into the 6th century scenario. Urban megacities from Lagos to Mumbai flash scarlet, their food import dependencies glaring. Global grain stocks, robust by ancient standards, still empty within 18 months of synchronized harvest failures. Global shipping, now a labyrinth of just-in-time logistics, struggles to reroute around ash-closed air corridors. Unlike medieval traders, 21st century markets operate on minutes-long information cycles. Panic speculations triple prices before the first shortfall even arrives at port. The model's synergy of speed and scale lays bare a sobering truth. The climate shock that toppled early empires could strike a hyper-connected world with even greater ferocity. Yet the exercise also uncovers tools medieval societies lacked. Satellite sensors spot sulfur clouds within hours. Diversified crops and gene-edited staples resist cold snaps. Strategic grain reserves and international relief funds shorten feedback loops between shortage and aid. You test a scenario in which policymakers, forewarned by real-time aerosol data, release 200 million metric tons of stored cereals and suspend biofuel mandates. The famine map cools from crimson to orange, riots flicker but stay local, and health system loads plateau below collapse thresholds. Preparation does not erase the shock, but it blunts its teeth. Proof that historical knowledge converted into infrastructure can save lives. Walking out of the modeling wing, you carry a thumb drive loaded with terabytes of visualizations, the cinematic proof of what a mega Krakatoa can do. Each frame translates chemistry into weather, weather into hunger, hunger into geopolitics. You remember the teacher in Anya asking for drills. Now you can hand her maps of where storm surges will likely hit, charts of crop varieties that best survive volcanic winters, templates for community seed vaults. The past has become a rehearsal space for the future, and you, a courier between centuries, deliver its annotated scripts. Outside, a summer storm gathers, and low clouds momentarily dim the sun. Passers-by quicken their steps, but don't look twice. They expect light to return the moment rain clears. You, however, view the grayness through a double lens, as transient drizzle and as an echo of a veil that once lingered for 18 months. That awareness is not paranoia, it is perspective. The simulation suite taught you the sky can turn against its dependence, but it also showed that foresight, grounded in granular evidence and propelled by computational imagination, can turn knowledge into shelter. You tighten your coat, feel the first cool drops on your skin, and trust that you now hold a blueprint for weathering to just the next storm, but the next twilight year. You leave the modeling lab with its storm tracks and crop failure maps still swirling in your mind, and you turn your attention to the next domino. The simulation knocked over disease. If cold, hunger, and migration reconfigured the world's food web, what did they do to its microbial ecology? You begin with a simple premise. Malnourished bodies and displaced communities form perfect tinder for contagion. Your task is to trace the spark. First stop is a genetics facility where ancient skeletons lie in sterile trays. Researchers here drill powder from the roots of molars taken from 6th century graveyards around the Mediterranean. You watch them dissolve bone dust, tease out fragmented DNA, and run it through next-generation sequencers. On the readout, you recognize a familiar genomic pattern. Yersinia pestis, the bacterium that causes bubonic plague. Its genetic clock tracks mutations like tree rings. The branch, dated to the mid-540s, sits noticeably older than strains that ravaged Europe in the Black Death. Already you see convergence. Climate models predicted rodent population booms in a cooler, wetter East Africa. Now the DNA points to the same region as ground zero. To test the linkage, you fly to the northern highlands of Ethiopia, where plague reservoirs still flicker in burrow systems. Ecologists set live traps for gerbils and measure flea loads under field microscopes. The populations spike after seasons that couple mild temperatures with sudden rain. Exactly the weather anomalies your volcanic winter created. You picture the bacteria colonizing swollen rodent hosts, then hitching a ride on fleas to camel caravans bound for Red Sea ports. From there, hungry sailors, lured north by grain shortages, carry the infection across the Mediterranean. The simulation's crimson shipping lanes morph into a living map of microbial transit. Next, you step aboard a small research vessel in the Nile Delta. Mud cores from oxbow lakes reveal layers rich in foraminifera. The tiny shells thrive during high salinity swings caused by erratic floods. Those same layers contain spikes in black carbon from funeral pyres and a sudden drop in human pollen indicators such as olive and wheat. Archaeobotanists read the pattern as simultaneous famine and mass mortality. The timing aligns with papyri mentioning the plague that came from the south. You scribble notes. Altered hydrology weakens harvests. Famine weakens immunity. Plague accelerates the toll. Yet you need a mechanism connecting chilling skies to bacterial bloom. In a Zurich lab, you open climate-controlled terrariums filled with Oropsilla montana fleas. Technicians adjust temperature and humidity dials to replicate conditions before and after the eruption. At cooler, moister settings, plague bacilli persist longer in the flea's proventriculus, blocking its gut so the insect regurgitates infected blood into every bite. Warmer, drier controls show the blockage dissolving sooner, shortening transmission windows. Watching the experiment, you see physiology convert meteorology into epidemiology. Each flea a tiny syringe made more lethal by volcanic fallout. Human behavior finishes the recipe. You return to Constantinople through the lens of archaeology. Excavators expose mass graves crammed in hasty layers, many coffins reused. Lead seals from grain sacks sit nearby, suggesting food distributions amid panic. Ceramic shards carry residues of Egyptian lentils rather than Anatolian wheat, signaling disrupted supply chains that mirrored the model's predictions. You trace streets narrowed by overpopulation. When refugees from frostbitten Balkans flooded the capital, they packed into insulae, already short on sanitation. A single rat nest in one granary could seed thousands of infections. Documents echo the dirt. In the Topkapi archive, you read Emperor Justinian's edicts slashing silk tariffs to stabilize commerce and ordering city prefects to finance mass burials. His chronicler, Procopius, records bodies stacked like cargo at the docks, and grain ships quarantined outside the harbor. You cross-check with Syriac letters from merchants in Antioch complaining of deserted markets. The language of economics becomes the language of triage, just as your model's civil unrest flags had warned. From Constantinople, the infection leaps west. You consult dendroprovenanced mortars in Bavarian churches. Isotopic analysis shows a dip in human-sourced lime in the 540s. Fewer builders, fewer renovations. Roman aqueducts, once maintained by tax revenue, crumble. You ride these supply line fractures south into the Italian peninsula, where Cassiodorus once pleaded for grain. Excavations at rural villas reveal abandoned olive presses. Pollen spectra replace olea with scrub oak, a botanical obituary for estate agriculture. Fewer farmers mean fewer cats to check rat populations, and the cycle tightens. But plague is not merely an urban story. It follows armies, too. In military papyri from Egypt, you notice sudden promotions as senior officers vanish from payrolls, likely dead, not pensioned. Campaigns against Persians stall because recruits desert plague-ridden barracks. Political geographers show you how frontier depopulation invites nomadic tribes to press borders, reshaping the map of power. Your earlier simulation flagged these geopolitical voids. Now brittle papyrus and toppled fort walls ground that forecast in stone. You shift from devastation to demography. Bioarchaeologists compare skeletal assemblages from before and after the epidemic. Average stature drops 2 inches. Enamel defects in teeth multiply. Signs of malnutrition in childhood cohorts born during the volcanic winter. Survival curves skew younger, indicating repeated waves culling adults. Such demographic damage lingers. Fewer laborers rebuild dikes. Fewer parents raise the next generation. Fewer taxpayers refill imperial treasuries. When later eruptions or wars strike, the buffer of human capital has already been shaved thin. Still, the story contains pockets of resilience. In the Arabian Peninsula, spared the worst chill and buoyed by trade rerouted around plague-stricken ports, merchant clans in Mecca prosper. You examine trade beads from desert way stations. Strontium isotopes trace them to Indian Ocean coasts, whose monsoon shipping rebounded first. Wealth accumulates, social networks thicken, and when a new monotheistic faith emerges, these caravans spread its verses faster than plague flees. Climate and disease thus sculpt ideological as well as biological landscapes. Returning to your modeling suite, you plug plague dynamics into the climate run. Rodent host parameters, flea survivability curves, refugee movements. The feedback loop worsens crop shortfalls as field hands die, and political stability metrics plunge. But when you add hypothetical interventions, rat-proof granaries, quarantine islands, diversified grain storage, the contagion's arc flattens. Medieval rulers lacked germ theory. Modern planners possess it, plus antibiotics and vaccines. You run a future scenario. Sulfur cloud equal to the 6th century load, but with rapid genomic surveillance and drone-delivered medical kits. Mortality drops by 2/3. Commerce rebounds in half the time. The lesson is clear. Knowledge cannot stop ash from rising, but it can stop microbes from riding the aftermath unchecked. You leave the institute at dusk. City lights shimmer on the river like rows of votive candles, silent witnesses to plagues that came and went. As pedestrians stream past, thousands of potential hosts brushing shoulders, you realize how thin the membrane between peace and pandemic remains. Yet you also carry hope. Genomes extracted from ancient teeth, climate models run on supercomputers, public health playbooks drafted from tombstones, all converging into an early warning network. The volcanic winter once turned fleas into empire slayers. Tomorrow, Satellites might turn sulfur clouds into a global siren, buying humanity the weeks it needs to outpace the next invisible army. That thought steadies you. History's darkest corridors are not dead ends. They are tunnels with guideposts left by those who stumbled through first. By reading their bones and their parchments, by simulating their skies and mapping their trade routes, you've learned to follow the contagion's path backward to its climatic spark, and forward to its societal transformations. And in doing so, you have armed yourself, and anyone willing to listen, with a strategy. Starve the microbe, shield the vulnerable, and keep the grain flowing, even when the sun goes dim. You leave the necropolis laboratories still smelling of ethanol and bone dust, and you point your compass toward the vast grasslands that once stretched unbroken from Manchuria to the Carpathians. The plague you just traced through flea-ridden holds did not start there, but the shock waves of famine and pestilence slammed hardest into the steppe's delicate ecology, turning a pastoral superhighway into a conveyor belt of migration. To see how, you swap PCR tubes for hoofprints. First, you travel upriver along the Orkhon Valley, cradle of countless nomad empires. Paleoecologists core ancient lakebeds and hand you pollen counts, juniper and feathergrass, species that flourish in cold, dry snaps, surge in the 530s and 540s, while moisture-loving sedges collapse. Isotopic ratios in equine teeth unearthed from nearby kurgans echo the same story. Heavier oxygen isotopes signal drought. Lighter carbon isotopes reveal horses forced to graze woody shrubs in place of their normal meadow forage. You picture herders counting rib bones on their prized geldings, deciding whether to cull or move. Scarcity makes the decision for them. Satellite spectroscopy adds a modern layer. Analysts feed vegetation data into algorithms that backcast biomass productivity. The 6th century frames flicker like a dying neon sign. Brown patches scab across what should be emerald expanses, indicating a 30% drop in forage yield. You overlay that map onto genetic networks of domestic herds. Mare mitochondria migrated west at exactly this time, hinting at massive livestock caravans on the march. Climate squeezed the pasture. Herds and their owners rolled westward seeking greener horizons. Archaeozoologists in Kazakhstan show you corrals abruptly abandoned, dung layers biofrozen in a final season. Carbon dating pins the exit between 545 and 560, right after your plague genomes appear in shipping manifest skeletons. The steppe didn't just lose grass, it lost people who once exchanged wool and horses with Persian merchants. Trade slackened, tribute to Chinese courts shriveled, and the vacuum invited fresh alliances of tribes, Uar, Roran remnants, maybe some Turkic groups, who began calling themselves by a new collective name, the Avars. To trace their trajectory, you ride west, metaphorically, through museum drawers. Hungarian soil reveals graves where skulls display fronto-occipital flattening, a cradle practice linked to Central Asian cultures, and grave goods mix silver Byzantine spoons with steppe-style arrowheads. Strontium signatures from tooth enamel match watersheds far east of the Ural River, proving these strangers were not native to Pannonia. Linguists pore over loanwords older than Magyar arrival. Slavic dialects adopt Turkic terms for harness parts and tribute, as if new overlords minted the vocabulary of subjugation. Now you open parchment. A Frankish chronicler complains in 558 that Hungarians, he had no proper label, ravaged the lower Danube, pressing Byzantine diplomats for gold. Those diplomats, desperate to redirect the storm, point the newcomers toward Italy's Lombards. In Ravenna's archives, you read how Lombard King Alboin seized that opening, abandoning Pannonia and rolling into a depopulated Italy, itself hollowed by the plague you studied earlier. One migration domino taps the next. Climate hits Steppe. Steppe tribes hit Byzantium. Byzantium deflects them into Gothic and Roman heartlands. Europe's ethnographic map redraws itself like wet ink bleeding across a palimpsest. Material culture keeps score. Gold tremises minted in Constantinople reappear in Avar hoards buried along the Tisa River, but clipped and pierced for stringing as ornaments. Tribute repurposed into badges of dominance. Meanwhile, in villages north of the Alps, archaeologists count sudden spikes in Slavic pottery, each kiln mark creeping west year by year. These are the farmers pushed ahead of the Avars, filling ecological niches left vacant by plague-thinned populations. Your plague curves become migration vectors. Your volcanic dust becomes demographic wind. You pivot from artifact to fortress. The ruins of Sirmium, once a glittering Roman city, show hasty earth ramparts slapped atop classical walls, siege layers of arrow points with trilobate Avar design, and burned grain silos dating to the 580s. Inside charred layers, coins of Emperor Maurice melt into slag, evidence of a defense overwhelmed. By 582, Avar rulers force the empire to pay an annual subsidy of 80,000 solidi. Tax records in Constantinople list new levies to cover the payout. The same ledgers cut allocations to frontier fortresses in Syria, inadvertently loosening imperial grip just as Arab tribes coalesced. A chill wind from Krakatoa thus nudged dominoes that would, decades later, open corridors for entirely new powers. But not every reaction favored steppe conquerors. In 626, when Avar Khagans marshal Slavs and Persians to besiege Constantinople, naval tactics perfected after earlier grain shortages, floating boom chains, Greek fire, repel them. The volcanic winter had taught the empire to stockpile, to innovate around scarcity. Siege failed. Morale cracked. Over the next century, Avar power waned, partially because the same climatic volatility that gifted them momentum now undercut their pasture base. Tree ring data from the Carpathians records another cold pulse in the 640s. Subsequent horse burials shrink in size, and elite grave goods lose diversity, signaling narrowed trade. The ecological roulette the Avars once rode now spun against them. You look eastward again, beyond the Caspian gates. Chinese Tang annals note embassies from Western Turks complaining that grazing lands turned to dust and salt. These envoys request textile subsidies in lieu of failed horse levies. The emperor, suspecting weakness, dispatches General Su Dingfang, whose cavalry, ironically bred on re-greened pastures after the eruption's chill faded, shatters the Western Turk Khaganate in 657. You map military victories onto climate proxies and see rhythm. Drought weakens nomads. Settled states strike back. Cycles repeat. Volcanoes thus serve both as slingshots and as brakes, depending on timing. Modern genetics illuminates human fallout. Genome-wide scans of contemporary Central European populations reveal small but distinct segments tracing to Inner Asian ancestry, with 6th and 7th century coalescent states. Those DNA threads weave through skulls in your earlier kurgans and into villagers buried under barrow mounds in Moravia. Cultural memory dims, but mitochondria remember the exodus. With these strands in hand, you rig another model. This one, socio-ecological. You input pasture yield drop, plague mortality, refugee flow, tribute absorption, and warfare expenditure. The result shows 2 fulcrum decades when imperial cash drains to buy peace, while agricultural recovery lags behind demographic rebound. Any further stress, another epidemic, a fiscal miscalculation, tips the system into fragmentation. History concurs. By the early 8th century, Byzantine control over the Balkans shrinks to coastal enclaves. Lombard duchies splinter Italy, and new Slavic principalities seed the map. Climate governed grass, grass governed horses, horses governed tribute, tribute governed state solvency, yet resilience surfaces again. In the Danube and Drava floodplains, pollen diagrams reveal a rebound of rye and millet in the 8th century, crops more tolerant of erratic seasons. Slavic farmers adopt ridge and furrow plowing, maximizing drainage in unpredictable rain patterns first triggered by volcanic-induced monsoon shifts. Cultural adaptation outruns environmental drag, hinting at the human agility that keeps civilizations from permanent collapse. Stepping back, you realize migrations are not mere side effects. They are engines retuning the cultural DNA of continents. The Avar wave, kicked loose by a dimmed sun and bolstered by plague-thinned borders, transplanted languages, crafts, and genetic lineages thousands of miles west. But their arc also teaches impermanence. Ecological volatility cuts both ways, empowering today's rider, unseating tomorrow's. You exit a Budapest museum where a reconstructed steppe saddle gleams beneath LED lights. Outside, tourists sip coffee on cobblestones laid atop what was once an Avar ring fort. Buses idle where war ponies once stamped frostbitten grass. The landscape feels placid, yet you now perceive its layered seams, each brick a residue of climatic mood swings. And as you watch storm clouds gather to the north, you recall the vegetation model's warning. A single sulfur spike can still parch the steppe and set new migrations in motion. Modern borders may look rigid, but forage lines and river flow still write the first drafts of geopolitics. Carrying that awareness home, you picture policy briefings that treat climate refugees not as speculative fiction, but as historical recurrence. Pastoralists in contemporary Mongolia already chase shrinking waterholes. Herders in the Sahel eye greener coastlines. Satellites can spot pasture fade. Rousseaued weeks before hunger pushes people outward. Drought insurance and mobile fodder depots can blunt migrations before they swell into conflict. The lesson from the Avars is not inevitability, it is contingency. When skies dimmed, those with the lightest footprint moved fastest, and those who prepared reserve grain held their ground longest. Your journey across the Eurasian grasslands completes the chain you began in a volcanic crater and traced through ice, bone, and code. A single eruption throttled photosynthesis, thinned immune systems, birthed pandemics, and then, rippling outward, unstitched the fabric of empires by tugging at the world's most sensitive ecological seam. Remembering that, you close your notebook on the train out of Budapest. Iron rails sing beneath you where once a nomad's horse galloped. The track ahead disappears into dusk, but you carry an old compass recalibrated by history. Watch the grass, follow the grain, and never underestimate the power of a chill wind to redraw the map beneath your feet. You leave the Danube basin with horsetack impressions still stamped in your imagination and head toward the Atlantic fringe, where the same volcanic shock and plague you have been following turned empty fields into invitations for new peoples. The road first carries you through hedge-lined lanes of southern England. Local museums display sword blades found in riverbeds, offerings, archaeologists say, from migrants who believed water sealed covenants with unseen gods. Metallurgy tests reveal the iron came from bogs in northern Germany, not Britain. That tells you who threw those weapons in. Seafarers who called themselves Angles, Saxons, and Jutes, arriving just as Romano-British farmsteads lay silent after famine and disease. You hike the remains of an abandoned villa near Cirencester. Roof tiles litter the floors, and mosaic fragments poke through nettles, But what strikes you are the animal bones. Pigs slaughtered at 6 months instead of the Roman standard of 18, and cow skulls split along a new pattern suggesting a continental butchery style. The site's last datable coin is from the 530s. Above that layer, charcoal and handmade pottery appear, thick-walled, shell-tempered, indistinct from shards dug along the Elbe. The plague that tore labor from estates and the chill that withered vineyards left real estate vacant. Migrant farmers slipped into the void, tilled lighter soils, and named villages in their own tongue, ending with Ham, Tartaman, Wick. Documents echo the dirt. In one of the final entries of the Gilda's Chronicle, you read a lament. Cities stood empty, except for howling of wolves. Modern researchers sometimes doubt his hyperbole, yet light detection and ranging surveys show tangles of early field boundaries overlaying Roman grids only after mid-6th century abandonment. You imagine British survivors retreating to highland redoubts while newcomers hacked rectangles into bracken, aided by iron plowshares unobtainable during Rome's final contractions. A post-volcanic sky, it seems, drew new lines not just on maps, but within soils themselves. You cross the channel to the Merovingian heartland. Here, plague and migration also rewrote hierarchies, but in a different key. Gold tremises struck by Clovis's heirs shrink in purity year by year, indicating bullion shortages after trade routes fractured. Yet archaeological census shows Frankish cemeteries expanding along former Roman highways, graves stuffed with glass beads from Italy and brooches from Kent. How did limited gold coexist with flourishing artisanal exchange? When you unroll parchment charters, you find the answer: land grants. Depopulation allowed Frankish kings to reward retainers with estates wrested from gone-silent Gallo-Roman senatorial lines. Loyalty bought with fields, not coins, sustained new power centers. Plague leaves its mark here, too. Genome work on skeletons from Saint-Laurent de la Cabrerise identifies the same Yersinia branch you traced to Constantinople. The pathogen crosses the Alps as caravans shrink and mountain passes fall to bandits. You visit digs at Chalon-sur-Saône, where layers of decapitated cattle suggest hurried abandonment of herds. Perhaps herdsmen died faster than their animals. Into that chaos ride Bavarian and Alemannic warbands, whose burial assemblages introduce spurs, stirrups, and new combat geometries. The cultural mosaic thickens even as coin flow thins. To the southwest, Visigothic Spain offers another texture. The volcanic winter's drought snaps irrigation canals inherited from Rome. Soil scientists core dried channels near Cartagena and find sediment pulses dated to the 540s, evidence of floods that came too late to rescue spring planting. Underfed communities revolt against tax collectors, as revealed by burnt estate archives in Mérida. Visigothic law codes from the next century suddenly emphasize communal responsibility for aqueduct maintenance, hinting that earlier infrastructure collapsed. Meanwhile, field surveys near Toledo uncover clusters of small church foundations with identical floor plans, likely built by bishops dispensing grain relief and evangelizing refugees from failed farms. Religious patronage thus replaces absent imperial bureaucracy. Even in these Iberian provinces, migrations reshape demography. Isotope analysis on tooth enamel from children in a necropolis at Recopolis shows some grew up along the Loire, others near the Tagus, proof that famine and insecurity triggered long-distance relocation within the peninsula. Their graves hold belt buckles with mixed motifs: Celtic scrolls, Gothic birds, and Mediterranean grapes. Hybrid art attests to hybrid identities. A cooling world doesn't freeze culture, it stirs it. You test these narratives in code again, feeding Western Europe's settlement densities into your socio-ecological model. Input plague mortality, volcanic winter harvest deficits, and inflows of continental migrants. The simulation redraws linguistic boundaries. Brittonic retreats west, Germanic leaps forward. Gallo-Roman vocabulary shrinks. Frankish legal phrases expand. Agricultural output plunges, rebounds, then exceeds pre-eruption levels once migrants introduce 3 field rotations perfected on the continent. Scarcity, paradoxically, seeds future abundance by forcing innovation and land redistribution. Real polity reflects the numbers. By the late 7th century, you see Anglo-Saxon kings minting silver ciatas with Christian symbols, treasure from new trade networks stretching to Frisia, a reminder that collapse opened lanes for fresh exchange rather than sealing borders. You open Bede's manuscripts and read how Northumbrian abbeys become centers of literacy. Famine memories likely drove monastic gardens to experiment with hardier barley strains, documented in marginalia as winter strong. Knowledge compounds in quiet cloisters where volcanic twilight once lingered. You pause at the Jorvik dig in modern York. Beneath Viking layers lie cellars, filled with Roman amphorae, then a sterile ash lens, then Anglo-Saxon timber halls. That ash, bagnage dated by tephrochronology, matches the 6th century Sulfate horizon. Standing in the trench, you feel chronology collapse into a single cross-section. Empire, emptiness, resilience. It dawns on you that the darkness did not simply erase, it reset. When the sun returned, the survivors, or the newcomers, wrote the operating system Europe still runs. Small kingdoms welded by oath, agrarian villages nucleated around halls, churches anchoring literacy, and a north-south trade bead that would someday underwrite Charlemagne's revival. But your exploration is not merely academic. Present-day parallels beckon. In Brittany, you meet coastal planners using LiDAR to map Roman salt pans long buried by dunes. They explain that rising seas, this century's own ecological stressor, might reclaim those marshes, and ancient dike alignments offer blueprints for adaptive aquaculture. The past becomes a toolbox. Ashes of former crises forged the templates for future resilience. You step into a food security workshop in Cambridge. Researchers flash GIS layers showing how 6th century settlement contraction aligns with modern rural depopulation zones suffering farm worker shortages today. They propose inheritance corridors, legal pathways for migrant laborers to receive land use rights, echoing Merovingian land grants that once rebooted economies. History advises, when fields lie fallow, invite hands that need them. On the final leg of your journey, you stand atop Dover's white cliffs at dusk. Ferries glide below, their wakes tracing routes older than nation-states. You picture the first angle ships nosing onto shingle beaches under a dimmed sun, and you realize how catastrophe can masquerade as invitation. They did not arrive to conquer an intact world. They filled a vacancy carved by cold, hunger, and microbes. In the quiet throb of ferry engines, you hear a modern corollary. Climate refugees tomorrow may not storm borders. They may step into jobs and villages that economic shrinkage has already emptied. As twilight deepens, you catalog the lessons this Atlantic rim offers. First, trauma rearranges space. Empty land is never empty for long. Second, hybridization is the rule, not the exception. Graves and glossaries prove mixture outlives purity. Third, improvisation saves. Whether ridge and furrow plows or monastic seed trials, invention thrives where old systems break. Finally, preparation counts. Societies that stockpiled grain, minted flexible currency, or democratized land ownership navigated the post-eruption maze better than those clinging to imperial formulas. You feel the wind pick up, the same wind that once carried ash from Krakatoa. It reminds you that nature's reach is planetary, but its impacts are local, sculpted by readiness and openness to change. You head back from the cliff edge, resolve tightening like drawstrings. Share this matrix of failure and adaptation with today's planners. Show them how a night-darkened sky over Java reshaped Britain, France, and Spain. If they grasp that chain, perhaps the next sulfur veil, or drought, or flood, will rewrite maps with fewer skulls and more seeds. You leave the white cliff coast and follow the ancient road west, toward the rain-polished hills where Celtic speech lingered after Germanic farms spread across the plains. The farther you travel, the fewer tiled hypocausts you find, and the more hut circles emerge, stone rings where smoke once coiled through thatched cones. At first glance, these upland homesteads feel timeless, but shovel probes reveal a break. Hearth ash, rich in hazelnut shells, from flourishing communities before the volcanic chill, and above it, a sterile silt lens a handspan thick, washed in by seasons of untended terraces. The hiatus marks the same years you tracked in abandoned Roman villas, yet here it feeds something different. Legend. Local guides lead you along an earthen ridge known as Beowulch I Sayathau, Pass of the Arrows. Tradition says a wounded war leader rallied his men here against yellow-haired invaders, then was ferried by boat to an otherworldly isle for healing. You scrape a test pit beside the path and expose decapitated wheat stems choked by frost crystals, carbon dated to the late 530s. Suddenly the myth setting, a land gone barren, a king struck down, feels less allegory and more reportage. When crops fail and graves multiply, storytellers often compress events into a single figure who takes the wound for everyone. You collect fragments of that story in dozens of tongues. A late Latin sermon from Wales speaks of civitas in vastitate missa, a realm sent into desolation, while an old Irish quatrain laments fields of hard clay where butter and honey had flowed. Breton bards sing of Brocéliande turned to desert of thorns. Each voice describes a wasteland emptied of fruit and flower, redeemed only when a once and future sovereign returns. Your mind loops back to the climate model's map. Drought cells blooming over western Britain just when these verses likely crystallized. Where data shows descending isotherms, poetry remembers withered orchards and cattle ribs. You press on to Tintagel's jagged promontory, where Atlantic swells hammer slate cliffs. Archaeologists here unearth shards of Phoenician amphorae, proof of long-distance trade even after Rome's legions left. Yet the ceramic sequence thins dramatically after 540, replaced by coarse local wares for almost a century. You picture storm-battered sailors bypassing famine ports, leaving cliff-top courts to sip watered ale instead of Levantine wine. When scribes later romanticized a king feasting on mead while his subjects starved, they may have encoded that abrupt loss of luxury the stratigraphy makes plain. In a damp upland valley, you join a paleoecology team auguring peat cores. Pollen counts plunge for oak and elm just after the eruption, replaced by heather and bracken, plants that colonize grazed-out soils. The core also holds a microscopic surge in bristle spines from pasture flies, insect proxies for decaying livestock. Coupled with plague burials from riverine cemeteries, the picture sharpens. A peninsula littered with carcasses beneath a dim sun. Oral culture strips away epidemiology's complexity and renders it as a single curse, the king's land and the king's body failing together. To test how memory travels, you pull out medieval manuscripts. In the Welsh Mabinogion, a hero named Manawydan finds the land rendered a vast silence after a magical mist. In a later French romance, the Fisher King's wound turns fields sterile until a grail seeker asks the right question. Each retelling drags the timeline forward. First Dark Age Britain, then crusading France. Yet the motif stands. A sovereign injured, a realm barren, a quest to heal both. The echo feels geological, like strata of narrative laid down by the same catalytic event. You wonder if the wound's location, thigh or groin in many versions, masks agricultural metaphor. A plowshare enters the earth as a sword enters flesh. When iron rusts in abandoned sheds, the land's fertility bleeds out. In a Cambridge library, you find marginalia on a 12th century copy of Geoffrey of Monmouth. Terra iacet vastata, rex vulnere gravi laborat. The land lies wasted. The king suffers a grievous wound. A tired monk, perhaps glancing at damp fields outside, underlined the words, iacet vastata. Climate may wound silently, but scribes give it a voice. Oral historians guide you to Cornish fishing villages where older residents still tell of the summer that never came, a phrase their grandparents attributed to tales of Arthur's last campaign. No date accompanies it, yet you sense the mythic clock ticking back to sub-Roman decades. When you describe the volcanic winter, elders nod as though a missing jigsaw piece just snapped in. Folklore, you realize, is not a broken compass. It is a low-resolution map preserving landmarks even when inscriptions fade. But myth did not paralyze everyone. On Dartmoor's fringe, you walk a longhouse rebuilt in the early 7th century from local granite, roofed in turf. Cheap, insulating, resilient. Charcoal analysis shows cooks favored gorse and dwarf birch, shrubs that thrived in the chilled microclimate. The community shrank, yes, but adapted, storing milk as hard cheese, weaving cloaks from hardy blackface sheep. When Arthurian poems mourn barren ground, they omit these quiet revolutions. Yet resilience coexisted with lamentation, each shaping the legend's double helix of loss and hope. You feed these observations into your model's cultural layer and watch narrative hotspots align with regions of maximal climate stress. Cornwall, Dyfed, Gwynedd. Places less ravaged, Kent's Chalkdowns, East Anglia's fens, spawn fewer wasteland myths and more pragmatic law codes you scrutinized earlier. Story density maps overlay almost perfectly onto isotherm anomalies from 536 to 547, as if bards were thermometers singing in decibels of despair. Late one evening, you climb Glastonbury Tor while mists coil around its tower. Local lore calls it Avalon, Isle of Apples. Yet pollen diagrams reveal orchards vanished here mid-6th century and did not rebound for centuries. The Tor becomes a weathered monument to absent fruit, fitting that healing apples of Avalon are legendary, not botanical. You leave a slice of quartz on the summit cairn, a silent marker joining geology to legend. Before departing the British West, you attend a small community workshop in Cardiff, where planners debate rewilding fallow farms. You share peat core graphs and the Fisher King story, showing how past ecological wounds inspired cultural ones. They ask how to seed narratives of recovery rather than decay. You suggest open-source storytelling festivals, celebrating river restoration as modern grail quests. Myth, you argue, once warned of blight. It can also advertise renewal. Back across the channel at an environmental humanities conference, you present your findings. Slides juxtapose ice core sulfate curves with medieval illuminations of a blighted land. Skeptics ask whether coincidence equals causality. You reply that legends are not spreadsheets but fault lines of memory. When multiple oral strata converge with physical proxies, the alignment deserves attention. A volcanologist in the audience later confides that her outreach programs now feature Arthurian parallels to explain aerosol impacts. Students remember the wounded king better than radiative forcing charts. As your train pulls from the station, you jot final reflections. Climate catastrophe tore social fabric, and folklore stitched emotional patches, preserving trauma in archetypes that outlived data's half-life. Where chronicles offered dates, tales offered metaphors. Together, they form a stereoscopic image of the past. And because myth travels farther than footnotes, it carries climate's cautionary signal across centuries. The countryside blurs into night, but you picture that ancient ridge in Wales where arrows once fell. Whether or not a historical war leader named Arthur died there matters less than why people needed him alive in memory, to promise that wastelands can green again. The promise remains relevant. Should another stratospheric eruption dim tomorrows, communities will craft fresh legends of nurses, engineers, or farmers who bear the wound for all. Your role, after tracing the first template, is to help ensure those future stories are seeded with lessons of adaptation, not only elegies for loss. You leave the rain-slick hills of Western Britain and board an eastbound ship, only to redirect your compass across an ocean. If volcanic twilight spawned legends of a wounded king in the Old World, what scars did it carve into cities that never read Latin? You sail westward in your mind's eye, over the gray Atlantic, skirting Caribbean reefs, and finally climb the central plateau of Mexico, where a metropolis once glittered with obsidian blades and lime-washed temples. Teotihuacan, the place where gods are born, now lies in quiet ruin, its avenue of the dead flanked by pyramids that catch first light like fossilized sunrises. You're here to follow the same climatic fingerprint that etched itself into Arthurian myth and see how it bled stone and fire into an American saga of collapse. Archaeologists welcome you at dawn atop the Pyramid of the Moon. They point to distant volcanic silhouettes, Popocatépetl, Iztaccíhuatl, snowcaps glowing pink. Beneath you, magnetometer surveys have traced neat apartment compounds built for a population that may have topped 125,000. Yet as trenches open, you notice a stark occupational horizon. Burn layers and smashed pottery shards clustered in the mid-6th century. Obsidian debitage, once produced with factory precision, suddenly declines, replaced by crude core flakes, a sign of retooling under duress. It's as if a craftsman's calloused hands went rigid in a single generation. Paleoecologists hand you pollen diagrams pulled from nearby Lake Texcoco. Maize pollen counts, steady for 3 centuries, nosedive around 535 CE, and stay low for nearly 3 decades. In their place rise chenopod and amaranth, drought-tolerant weeds scraped from lake beds when staple crops failed. Sediments grow dustier, grain size coarser, indicating exposed shorelines and fierce winds. You remember the British peat core bristling with dead pasture flies. Here, dust replaces flies, but both are signatures of the same planetary chill. Volcanic aerosols dim the sun, global temperatures sink, monsoons falter, and the basin of Mexico dries like a cracked basin left on a hearth. You kneel beside an excavation in the merchant's barrio. Charcoal flecks dot a floor where wooden lintels once supported a market hall. Radiocarbon dates cluster tightly around 550 CE. The very moment tree rings 5,000 miles away showed their narrowest band. Chemical tests reveal elevated manganese, pointing to intense flames fed by plaster pigments. Looting cuts slash storage rooms. Smashed cacao jars litter entryways. Sometime after the first failed harvests, residents apparently torched the marketplace, perhaps in riot or revolt. Famine undermines trust. Once prosperous traders become scapegoats just as, across the Atlantic, Saxon farmers blamed Romano-British landowners for empty granaries. Artifacts echo desperation. Talud tablero panels on smaller temples are hacked off, probably repurposed as rubble fill. Skeletons in hurried burials bear blade marks on vertebrae and ribs, evidence of close-quartered violence. Stable isotope analysis of their bones shows childhood diets high in protein, but adult diets deficient, reflecting shrinking food reserves. You imagine a young artisan raised on maize and turkey suddenly forced to forage on quilites and scrub hairs, his body recording the shift in its collagen. To gauge scale, you consult obsidian sourcing data. Teotihuacan once monopolized Pachuca's green glass, controlling distribution through state workshops. After 540 CE, trade nodules from Pachuca plummet across Mesoamerican sites, replaced by local gray obsidian. Political control has fractured. Regional lords sidestep the metropolis, mirroring how Frankish gold flows rerouted when Merovingian mints lost luster. Climate doesn't merely starve stomachs, it starves hierarchies by thinning the arteries of commerce. You visit a laboratory where volcanic ash from Greenland cores sits under lock. Geochemists compare its sulfur signature to tephra from El Chichon and Ilopango, Central American candidates for local disruption. Ilopango's eruption around 431 CE predates your window, but El Chichon's smaller burps in the mid-6th century may have compounded global haze. Dual insults: Sulawesi Krakatoa aerosols circling both hemispheres and a nearer plume clouding regional skies could tighten the noose around Teotihuacan's rain-fed Chinampas. You feed combined forcing into a regional climate model. Precipitation sinks 20%, evapotranspiration soars under erratic heat, and maize growing degree days fall below viability 3 out of every 5 years. Margins thin until a single locust swarm, or one more ash-dimmed season, tips the balance. Seeking human context, you hike to smaller settlements ringing the valley. At Xochicalco and Cacaxtla, murals bloom in fresh polychrome just decades after Teotihuacan's fires. Warriors in jaguar pelts parade beside captives. Dynastic emblems previously absent now flaunt on lintels. You recognize the pattern. When a center collapses, peripheries seize narrative power, exactly as post-Roman petty kingdoms minted myths of noble ancestry. Here, new elites in rising city-states co-opt Teotihuacan's architectural grammar, plazas, talud tablero facades, but tweak iconography to claim cosmological mandate. Collapse becomes catalyst for regional renaissance, albeit one forged in charcoal. Anthropologists guide you through burial caves in the Sierra Madre. Crania bound in infant cloth exhibit cranial modification styles distinct from Teotihuacan norms, their owners possibly migrants fleeing drought. Strontium isotopes trace them to highland Chiapas and lowland Veracruz. Some graves hold pilon-style pottery bearing hybrid motifs, blending Gulf Coast spirals with Central Highland steppe frets. Migration transforms culture mosaically, again paralleling Avar and Anglo-Saxon flows you tracked earlier. Everywhere, the volcanic winter proved no respecter of continental divides. You open the Popol Vuh, transcribed centuries later by Keiche scribes, and read of faces blackened by ash and days without dawn. Though mythic, the imagery resonates with geological timelines. Oral memory in Mesoamerica, like Arthurian legend in Europe, seems to have compressed atmospheric trauma into cosmological allegory. Gods reshaping suns, heroes climbing smoky mountains, myth as seismograph, still quivering long after the quake. Back on the pyramid summit at sunset, you watch tour buses crawl like beetles along the Avenue of the Dead, their headlights glinting off weathered limestone. Most visitors carry snapshots home. You carry synchronicity. The same sulfate spike that carved wasteland legends in Britain aligns with the coal-black charcoal you sifted here. The same dearth that forced Celtic shepherds up bleak hills drove maize farmers onto poorer slopes or into revolt. Climate shock proved borderless, yet its cultural receipts, wounded kings, fiery marketplaces, felt regional, tailored to each society's fault lines. You test one final hypothesis: resilience pathways. In Britain, adaptation meant ridge and furrow plow, monastic seed trials, and new social contracts. What of the basin of Mexico? Lakebed cores show Chinampa agriculture rebounds a century later, evidenced by a resurgence in Zea maize pollen and cut reed silicates. Later, Toltec rulers re-engineer canals, and Aztec engineers will perfect them 7 centuries on. Collapse, then, was punctuation, not epilogue. Volcanic shadow pruned an empire, but irrigated the imagination of successors. As you leave Teotihuacan's moonlit causeway, you jot lessons for modern planners on your field tablet. First, diversify staples. Reliance on maize or wheat alone courts disaster when climate flicks its switch. Second, decentralize supply chains. When one hub fails, peripheral resilience keeps society breathing. Third, encode memory. Legends of darkness may outlast spreadsheets, but both should be archived because future engineers may need myth's emotional voltage as much as data's wiring diagram. Your taxi rumbles toward Mexico City. Neon storefronts blur past. Taquerias, smartphone boutiques, seed bank offices. Testaments to an urban organism that rebounded where Teotihuacan once died. You picture sulfur clouds gathering over Krakatoa's caldera again. Imagine jets grounded and soybean yields dropping abroad. Somewhere, descendants of migrants, merchants, and myth-makers will inherit that sky. If they've read the story etched in burned pottery and frostbitten peat, they'll know collapse isn't foreordained. It's a caution sign flashing, reroute. And if they haven't, perhaps your stitched-together chronicle will serve. A map showing how one dim sun upset 2 continents, yet sowed the seeds for the next green dawn. You leave the silence of Teotihuacan's moonlit pyramids and pivot your internal compass once more, this time toward the sun-blasted uplands of southern Arabia. If volcanic haze felled a Mesoamerican powerhouse, what did it do to the caravan civilizations that stitched Africa, India, and the Mediterranean, together with frankincense and myrrh? You picture a map rolled across your desk. Draw an arc from the Horn of Africa northeast to the Empty Quarter, and you land in a region that, on the eve of the 6th century chill, was both garden and crossroads. Your next case study waits among the crumbling sluice gates of the Great Marib Dam. You fly into Sana'a, then bump east in a rust-specked land cruiser along wadis lined with acacia. At the outskirts of Marib, you see it, a 2,800-foot earthen embankment, battered yet unmistakably monumental. For more than a millennium, this dam captured monsoon runoff from the highlands, fanning it through a maze of stone weirs into fields of sorghum and date palms. Engineers escort you atop the breach first noticed by archaeologists in tailings of silted sand. OSL dating pins its catastrophic failure to somewhere between 575 and 585 CE. Uncomfortably close to the second sulfur pulse you modeled in Greenland ice. Drought weakens embankments. A flash flood punches through. Irrigation collapses. The story sketches itself in sediment. Geoarchaeologists core the downstream alluvium and hand you laminae charts. Pre-536 layers show fine particles, evidence of stable, slow deposition in calm canals. Layers after 540 grow coarser and interleave with charcoal, implying gully erosion and field burn-offs. By 580, the cores thicken with wind-blown quartz grains carried from the desert, sign that gardens turned back into dunes. You touch those grains and imagine farmers watching canals run dry while volcanic dusk still dulled midday light. Historical sources whisper parallel grief. In a pre-Islamic South Arabian inscription, you read the lament of a king who prayed to Athtar for the return of waters. Byzantine chroniclers record embassies from Himyar begging for grain relief in 546 CE. Even the Quran, compiled later, mentions a flood of Arim that scattered the Sabaeans. You tally lines of evidence: dam damage, pollen crash, trade embassy, scripture, all converge on decades when climate hammered hydraulic society. Trade journals of the day spoke in incense, not ink. To follow that scent, you hike to the former terminus of the frankincense road at Kani by the Gulf of Aden. Port excavations reveal storage jars stamped with Himyarite monograms tapering off in the 550s, replaced by Ethiopian imports. When volcanic aerosols chilled global seas, Indian Ocean monsoons grew erratic, sailors hesitated, and aromatics spoiled on quayside pallets. Caravan routes rerouted north toward an upstart town called Mecca that sat beside a reliable Zamzam well and controlled a pass clear of seasonal floods. Climate didn't just dry fields, it rewired commerce. You ride a camel segment of that route, feeling how portable wealth becomes in hard times. Aromatics in goatskin pouches, jewelry stitched into saddlebags. Geneticists later confirmed that haplogroups common in southwest Arabia spike in modern Hijaz populations. Migration left footprints not just on dunes, but in chromosomes. Oral tradition preserves it too. Tribal poems of the Juhayna and Kinda speak of the day we folded our tents when the waters betrayed us. Fold once, move twice, and within a generation, grandchildren forget the taste of Marib dates, but remember which clan managed waterskins in the Hijaz. You reach Mecca at nightfall, today a blaze of neon, then a modest sanctuary town orbiting the Kaaba. Early Islamic sources describe Meccan clans, especially the Quraysh, mediating caravan tolls and winter-summer trade circuits. Economists among your working group model a surge in toll revenue starting about 560 CCE, matching exactly when incense trucks from Marib fade from Gulf manifests. Climate-induced migration hands the Quraysh a monopoly, and with monopoly comes the capital to bankroll social welfare. Grain stocks for widows, loan forgiveness in lean years, alliances cemented at communal banquets. You recognize resilience mechanics you traced in British monasteries, here transposed into tribal commerce. Next, you enter Medina's date groves, guided by archaeobotanists crunching phytolith samples. They show irrigation trenches expanded in the late 6th century, cut precisely where volcanic chill made Marib's canals obsolete. Soil chemistry reveals a spike in phosphorus, organic fertilizer from camel dung, suggesting migrant pastoralists retooled as oasis farmers. The frontier between herder and planter blurs, and new social contracts spread. Communal water rights, zakat-like alms even before Islam formalized them. Climate fosters institutional prototypes that a later prophet will scale into doctrine. You step into the lab of a philologist dissecting the Quran's early Meccan surahs. He points out verses railing against hoarders who devour the inheritance of the poor. In a society jolted by refugee inflows and supply chain shocks, moral outrage at wealth concentration becomes religious urgency. Likewise, eschatological images of smoke covering the people, or the sun folded up, resonate hauntingly with still-remembered volcanic gloom. Revelation dawns vocabulary honed by climate trauma. To trace contagion, you revisit plague DNA. Emirati tombs at Jebel Buhais yield Yersinia pestis strains genetically close to those in Egyptian skeletons, arriving by 543 CE through Red Sea routes. South Arabian refugees, crowding new oases, likely served as amplifiers, just as Teotihuacan's starving neighborhoods incubated revolt. The disease scythes weaker tribes. Survivors coalesce around stronger patron lineages, accelerating the Quraysh's ascent. Volcanic winter, dam collapse, plague. 3 chords in a minor key that set the rhythm for a nascent monotheism. By 610 CE, Muhammad begins preaching. Social historians argue his message of social leveling and radical charity crystallizes precisely because traditional Sabaean and Himyarite elites had failed their people during environmental disaster. When Meccan oligarchs resist, refugees again become catalysts. Emigrants to Medina, many descended from drought-pushed tribes, carry with them the communal ethos forged in crisis-driven date gardens. The Constitution of Medina, allocating tax burdens and defense pacts across faith lines, reads like a legal fuse soldered in the heat of ecological uncertainty. You feed these threads into your socio-ecological simulation. Decrease monsoon predictability, insert dam failure, cut incense trade by 50%, add plague mortality, then track political religious innovation metrics. A pulse flashes in Western Arabia, scoring high on community redistribution and prophetic charisma indices. Run the model without the climate inputs and charisma flickers, but rarely stabilizes. Social friction never reaches ignition temperature. You realize causation is never singular, but the sulfur veil over Krakatoa tilled deeper furrows for new seeds of faith. Before leaving Yemen, you visit a modern engineering project, a concrete dam rising upstream of ancient Ma'rib's ruins. Workers explain how photovoltaic pumps will lift water onto terraces re-greened with drip lines. They know their ancestors' dam crumbled. Some blame locusts, others divine wrath. You tell them of ice cores in faraway labs that traced invisible aerosols to a forgotten Indonesian volcano. They chuckle, half skeptical, yet insist on building overflow channels wider than the ancients, a modest tithe to uncertainty. At a conference in Muscat, you present your journey. Ice sulfate peaks, hydraulic collapse, incense rerouting, emergence of Islam. Delegates from climate policy circles ask what lesson binds them. You answer, infrastructure is faith in stone. When nature negates that faith, adaptive social ideals can turn loss into launchpads, but only if stories preserve memory of the breach. The Quran recalls the flood of Arim. Future textbooks should recall Krakatoa. Flying out over the Arabian Sea, you peer down at shipping lanes glinting silver. Tankers now carry crude instead of frankincense, but choke points remain. The Bab al-Mandab, Strait of Hormuz. A single prolonged disruption, whether sulfur veil or cyber attack, could again reroute global currents of value. You have traced how 6th century climate chaos birthed a religion that now guides nearly 2 billion souls. The scale humbles you. The pattern steadies you. Systems fail. Migrants move. Stories bloom. And new orders rise from irrigated dust. As the cabin lights dim, you draft a final note. When the next dam breaks, literal or figurative, remember Marib. Build overflow. Welcome the traveler. And listen for prophets. History suggests they often speak first in the accents of the displaced. You lift off from Muscat with the scent of frankincense still in your clothes and a patchwork of 6th century ruins mapped in your head. Looking down, tanker wake is scribbled silver lines across the Arabian Sea, echoes of the spice convoys and incense dhows you've just traced. Yet instead of following one more historic ripple, you climb into the thinner air of synthesis, The stories you've gathered, fields gone barren in Britain, pyramids burning in Mexico, dams bursting in Yemen, aren't just curiosities from a bad century. They're laboratory notes from a global stress test. Now, cruising above cloud tops, you start asking what those notes spell for a world lit by data centers and stitched together by just-in-time trade. You begin by tallying the mechanisms. First comes the physical blow. A caldera tears open, hurling sulfur high enough to ride the equatorial jet stream. Sunlight dims by a few percentage points, and global mean temperature drops faster than any modern heat wave rises. Monsoons stagger, river regimes flip, sea ice creeps outward. Crop calendars misfire, whether maize in the basin of Mexico or wheat on the North Atlantic fringe. Next arrives the biological echo. Malnutrition trims immune systems, rodent hosts surge, bacteria exploit the new circuits of desperation. Trade lanes become infection corridors. Fear compounds scarcity. Finally, the social dominoes fall. Tax revenues sink, armies shrink. Refugees pull up stakes, ideologies reconfigure, and fresh powers sprout in the cracks. The whole sequence, from ash cloud to regime change, can unfold in less than a generation, yet cast shadows for centuries. You test that timeline against modern baselines. Today, half of the planet's calories derive from just 3 crops: rice, wheat, and corn, each cultivated in climate bands narrower than their ancestors' genetic toolbox. Satellite-guided combines optimize yields, but leave little slack. Stored grain measured in months, not years, underwrites urban life for 7 billion people. International shipping, concentrated through a handful of choke points, moves 90% of traded goods. Commercial aviation, grounded for days by a mild Icelandic eruption in 2010, delivers vaccines, organ transplants, and executives who sign grain futures. As you weigh these metrics, you realize the 6th century system, primitive as it was, enjoyed redundancies. Modern logistics sacrificed for speed. You picture a Krakatoa-class column punching through the stratosphere tomorrow. Within hours, spectral sensors on weather satellites would register the sulfur bloom. Tweets would flare from volcanologists, and trading algorithms would sniff risk. Yet the first grocery shelf would empty before policy memos cleared committee, because supply chains rely on schedule, not inventory. Container ships blocked by ash-laden skies would divert to already congested ports. Airlines would cancel flights. Passenger jets, which also carry half of all air freight, would strand insulin shipments. Meanwhile, global fertilizer markets, tied to natural gas prices and just beginning to pivot toward green ammonia, would spike, choking next season's yields. You switch lenses from vulnerability to opportunity. The 6th century record shows resilient circuits you can retrofit. Diversify staples. Ethiopian highlanders kept teff alive when wheat failed. Andean farmers banked on quinoa. Gene banks now hold tens of thousands of drought, cold, and salt-tolerant varieties. You envision regional seed vaults linked by drone corridors that bypass ash-shrouded hubs. Decentralize energy. Medieval charcoal burners shifted from oak to heather when forests died. Today's grid can shift from gas peakers to distributed solar plus battery, provided panels sit outside the ash fallout zone or are broomed clean by autonomous rovers. Reinforce local water. The Qanats of Persia and the Chinampas of Mexico proved that passive hydraulics survive where pumped canals fail. Modern equivalents could be solar stills and atmospheric water harvesters seeded across arid belts. Institutional mimicry matters too. When Roman tax circuits snapped, monastic orders became granary, clinic, and library. In Yemen, oasis councils rewrote water rights long before formal scripture codified zakat. You imagine civic resilience guilds embedded inside city blocks, volunteer units trained to manage microgrids, rooftop gardens, first aid centers. Each guild stores encrypted manuals on rugged tablets and rotates emergency caches. During blue sky years, they run street fairs and compost programs. When skies darken, they switch to ration trustees and disease sentinels. This is not disaster prepper fiction. It's a civilian analog to naval reserves, modeled on monasteries and caravanserai. You note the psychological vector. Myth travels faster than policy. 6th century Britons wove the Fisher King. Mesoamericans painted God-stirring sun disks. Quraysh poets sang of the Arim flood. Each narrative preserved climatological truth in emotional code. Modern public health campaigns work when they harness story. Think of Rosie the Riveter for industrial mobilization or seatbelt PSAs built around family drama. You sketch a transmedia project that follows a fictional nurse across hemispheres during a long twilight, delivering evidence-based tips through graphic novels, radio dramas, and TikTok riffs. If algorithms amplify outrage by default, feed them tales of cooperation instead. The flight attendant pours coffee. Turbulence rattles the cup. An embodied reminder that the air outside, Tiamat streaked with invisible jet streams, is the same conveyor belt that once lofted sulfur from Krakatoa to Greenland. You stir the foam and reflect on governance. International treaties regulate nuclear tests and ozone-eating chemicals. None bind states to share aerosol data or eruption intelligence within minutes. You draft a notional stratospheric hazard accord, mandating real-time satellite feeds, open-source climate modeling, and pooled grain reserves. Contributions scale to GDP. Withdrawals trigger automatic debt forbearance, preventing the grain-for-gold spirals that bled Byzantium. Finance enters the frame. Historical calamities minted fortunes for those holding scarce coin or land. In a data-driven age, the equivalent asset might be low-latency weather intel paired with algorithmic trading. To prevent profiteering that starves the vulnerable, you envision circuit breakers. Once commodity volatility crosses a threshold linked to verified climatic disruption, automated policy kicks in. Export bans lifted, strategic stocks released, futures markets paused. You recall how Justinian's edicts froze grain prices, yet failed because reserves were too thin. High-frequency guardrails only work if warehouses are full. Stockpiling seems old-fashioned until you realize lithium and cloud servers can't be eaten. A ping on your laptop signals fresh research. Geophysicists have revised the eruption recurrence interval for the Phlegraean fields near Naples. Probability of a major event within the century edges upward. 10 million residents live within ashfall range, and global pharmaceutical supply chains source active ingredients from factories around the Bay of Naples. You tab over to insurance sector dashboards. Coverage models treat volcanic risk as regional, not systemic. You add a note. Update catastrophe bond criteria to include secondary effect clauses, crop loss, trade paralysis, migration surges. Migration, you recall, is the human Earth's thermostat valve. 6th century Avars rode horses westward. Anglo-Saxons filled Britain's empty cornfields. South Arabian tribes seeded Islam's caravan pietism. Migration today carries stigma in political discourse, but your historical ledger frames it as adaptation. You sketch an anticipatory migration policy. Bilateral agreements that trigger visa expansions and housing credits once predefined climate metrics trip. Think of it as earthquake retrofitting for demography, engineered flexibility rather than emergency exodus. As descent begins, city lights grid the night. Power, data, food, water, all pulsing in real time. You close your notebook with one final synthesis. The 6th century catastrophe taught that a single volcanic throat can clear civilization's throat, forcing it to speak new dialects of survival. The question isn't whether another mega eruption will come. Geological clocks promise it will. The question is whether you, civil engineer, coder, teacher, mayor, parent, treat that promise as distant trivia or design constraint. The ancestors you've followed for months left warnings in charcoal, legend, scripture, and DNA. Their message distills to a sentence: prepare for the sky to fail, and the ground will still sustain you. The runway lights flare, wheels chirp, and as you taxi toward the terminal's glow, you decide the work begins not tomorrow, but the moment the seatbelt sign clicks off. You step off the red-eye with the sulfur lessons still buzzing in your ears, but the hometown terminal greets you with espresso kiosks and LED arrival boards, proof that normal life is a fragile miracle. Instead of heading straight for bed, you open your laptop and pull up a satellite map peppered with orange triangles. Each icon marks a restless giant. Yellowstone in Wyoming, Long Valley in California, Taupo in New Zealand, Campi Flegrei skulking under Naples, and Toba's drowned caldera in Sumatra. The 6th century blast you have been following was a tier below these monsters. Now you ask the obvious question: what happens if one of them decides to write the next chapter? You start with Yellowstone because its myth already stalks pop culture. USGS webcams show elk grazing over steaming vents, postcard calm above a magma body 20 times larger than Krakatoa's. You know the odds, maybe one cataclysmic eruption every 100,000 years. But odds did not comfort the Romans when Vesuvius slept under their vineyards. Geophysicists invite you to a borehole lab outside the park. Laser strain meters record the ground rising and falling like a slow tide. Centimeters a year. Nothing alarming. Yet a reminder that the caldera breathes. Infrasound sensors capture pops you can't hear. Each microquake is a syllable in magma's underground telegram. The scientists decode it daily, but budget cuts shave hours off lab shifts, and you mark that down as a vulnerability. Vigilance is expensive, complacency cheap. You fly to Italy next, where Campi Flegrei, the fields of fire, sprawls beneath apartment blocks and soccer fields. A civil protection officer hands you an evacuation map. 500,000 residents live inside the red zone. Buses, trains, and ferries are color-coded by 30-minute windows. You walk the narrow lanes and count how many cars block the route by lunchtime. A single double-parked van could freeze the convoy. Planning looks good on PowerPoint. Asphalt reality differs. You remember how Marib's engineers never imagined both drought and flood hitting in the same decade. Layered crises gum gears faster than any one threat alone. Long Valley, your next stop, sits quiet under the high Sierra sky. Here, geologists have drilled ultra-deep cores to read helium isotopes, magma's calling card, rising through fractures. Helium spikes climb on one plot, dip on another. Interpretation is art as much as math. You realize early warning will never be like a fire alarm you can yank after smelling smoke. Instead, society will receive a stock ticker crawl of probabilities: 5% this month, 8% next. The world's attention span, meanwhile, flickers in seconds. You jot a note: how to translate probabilistic dread into steady investment rather than panicked headlines. With site visits logged, you rerun the climate models you used for the 6th century event. But this time, you load a caldera scenario ejecting 1,000 cubic kilometers of ash, 25 times Krakatoa. Stratospheric sulfate soars to levels that shave 6 degrees Fahrenheit off global averages for 3 consecutive summers. Corn belts in the Midwest fail outright. Rice yields in the Mekong Delta plummet. Photos of orange sunsets flood social media until low-orbit satellites start dropping as atmospheric drag spikes. Fiber optic cables crossing the Pacific suffer repeated outages from subaqueous landslides triggered by ash-laden turbidity currents. Within weeks, you watch simulated GDP graphs nosedive more steeply than any recession curve. 100 million climate migrants appear in the model's lower confidence bands before the first winter is over. Economic analysts in gray suits ask you for numbers. You quote them the latest insurance industry estimate. A super-eruption could bury 8% of global capital stock under ash or supply chain paralysis in the first year alone. They blink, note it down, then pivot to quarterly earnings. You understand. Fiduciary duty rarely stretches to geologic time, so you speak their dialect. Point out that food futures and semiconductor stocks hinge on the same high-vacuum lithography tools manufactured near Naples. If Campiflagre sneezes, chips choke, and algorithmic trading desks go dark. Now you have their attention. Policymakers want levers, not laments. You propose a layered shield. First, planetary surveillance equal to orbital missile defense. Hyperspectral satellites sweeping every plume. LiDAR aircraft probing aerosol heights. A global network of muon detectors mapping magma inflation in real time. Second, distributed reserves. Grain, fertilizer, and critical minerals warehoused in politically stable, geologically quiet regions. Third, ash-safe corridors. Pre-negotiated shipping and flight paths that skirt likely fallout cones. Nations would trade landing rights and naval escorts for the promise of continued food imports if they end up downwind. It's an insurance swap on a planetary scale. Sociologists remind you of narrative power. Just as Arthurian myth encoded environmental trauma, today's stories will shape how civilians respond to CGI news feeds of ash towers. You partner with game designers to build a multiplayer simulation where players manage city blocks under a darkening sky. Points accrue for sharing water, debits for hoarding masks. The beta launch draws Twitch streamers who convert lessons into memes. Yaw yeet the yeast stockpile before the crust turns dust. It's silly, but so were medieval mummers' plays that nonetheless carried public health advice about plague saints. Humor rides where sermons stall. You test tech fixes, too. Material scientists show you basalt fiber roofs that shed ash at twice the rate of conventional shingles, and electrostatic fences that drop airborne particulates around greenhouse rows. Engineers scale greenhouse LEDs toward the blue spectrum to compensate for red-filtered sunlight under aerosol haze. These are marginal gains, but stack enough and you buy another harvest cycle, time that once meant survival for Teotihuacan and could again for Silicon Valley lettuce farms. While you're counting lumens, epidemiologists remind you of lung tissue. Fine ash embeds silica microblades inside alveoli. One more vector for infection in a world already flirting with antibiotic resistance. You join a workshop on rapid fabric respirator masks, printable on FDM machines using cornstarch polymer. The design files fit on a thumb drive smaller than a car key. Distribution could piggyback on the ham radio networks you earmarked for emergency mesh internet. You think of Byzantine plague pits and decide any future timeline without mass graves is worth cluttering garages with printers and PLA spools. Late one night, you video call a Maori elder near Taupo. She says her ancestors tell of a lake born from fire so bright it burned the sky into new stars. She asks what stories you plan to leave for your descendants. You hesitate, then realize spreadsheets won't spark courage when dusk stays past noon. So you pledge to write guidelines that read like campfire lore. Where to find seeds, how to clear gutters, why strangers become cousins when ash turns roads to rivers. It feels small, but singing seeds into lore kept Andean terraces alive through long droughts. Finally, you convene a mock cabinet exercise. Representatives from agriculture, defense, infrastructure, culture, tech, and public health sit at a circular table. A red card means super-eruption imminent. A yellow card signals false alarm. You flip the yellow first. Finance wants to wait. Media wants the scoop. Scientists disagree over plume height. The room stalls. Then you flash the red. Silence, then a scramble. Too late for orderly rollout. When the drill ends, everyone sees that the real discipline is acting on the yellow, mobilizing on uncertainty, spending political capital before certainty arrives. You call it the ash pivot and vow to adopt it personally. Invest, prepare, rehearse, even when skies look blue. You leave the briefing and step outside. City lights smear upward where moisture thickens the night air. You picture those lights filtered through sulfate mist, still shining but scattered, softer, like lampions guiding sailors through fog. You breathe in, grateful for clear lungs, and whisper the distilled directive that has pursued you from Rakata's pumice to Marib's broken spillway. Expect the sky to fail, then build so people don't. That sentence, you realize, is the last brick in the bridge from a forgotten dark age to a still bright future. And because you carry it now, the next time the world dims, someone else may step into dawn instead of legend. Thanks for journeying through history's darkest year with us. I hope the quiet storytelling eased you toward rest. If you're still awake, breathe deeply, feel the pillow cradle your head, and let the past drift away like mist at dawn. Before you close your eyes, please scroll down and share a gentle thought or your favorite calming ritual in the comments. Your note might help someone else drift off too. Remember to like and subscribe so you can join our next midnight adventure. Until then, may your dreams be bright, your night peaceful, and your morning refreshed. Good night, dear friends.